Good evening. Good evening. Very good evening. So hope everything is fine. Chalo, chalo. Is everything fine, my dear students? Is everything fine? Great. Chalo. So let's start. And so already you know that engineering mechanics is going on plus from 10th February, I'll be starting basic thermodynamics. The date is announced on 10th February on plus. Again, it is on plus. Timings will be 8:30 p.m. because many students requested me, okay, sir, please take in the evening because they are free generally in the evening. Okay. Chal. Okay, okay. Shall we proceed? Bolo, bolo, bolo. Shall we proceed, dear students? Shall we proceed? Okay. So I have Tanuj, I have announced the date also. Just check. So this will be for complete engineering services, GATE, CSC mains, that is IRMS. For all, this course will be this is designed. Okay. Abhi start karenge, sirs. Now, my dear students, hope your preparation is going on very well. First of all, very good evening to all of you. Without wasting time, let's proceed. Okay. Chalo. So what I try to do is, dear students, what I try to do is, I'll give you theory, whatever is required, whatever is important. I will not waste your time. So I will not take hours together. No. So I will not take hours together. Whatever is required in a short time period, whatever is possible, whatever the revision is possible, we'll try to do that. Okay? Okay, sir? Industrial revision chahiye aapko. Nimmakayala Dinesh Reddy said anything extra from previous. Definitely the coming thermo, you have extra conventional questions, some extra objective questions and old questions. Some of the old questions I am removing and I have added some new questions. So definitely it will be altogether something, a mixture of new and old. Okay, anything more? Anything more? Anything more? Naina? Abhi start kare, sirs. Okay. Good, 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 good. Sir, please provide some PDF and solution from last revision. Okay, okay, okay. I have to check. I have to check once. I have to check. Okay, now straight away we'll go to thermodynamics. Let us not waste time revision. So I'll be touching only important areas and that too in a small time. I will not be taking hours together. That is very clear. That is very clear because if I start taking 8 hours, 10 hours, so you have to revise. So only just maybe 1 hour, 2 hour you can revise happily. That is fine. Now, dekho, let's proceed, sirs. You know, my dear students, thermodynamics is basically the science of energy transfer and its effects on properties. So energy transfer or energy interaction is of two types. One is heat interaction and other is work interaction. And one more thing, I'm not going into the details. All details are covered in 80 hours of my thermo classes. And on unacademy, it is one of the highly watched courses on Plus. So therefore, here I will not go into the details. And and one more thing, those who want like my notes and to be in contact with me, like I'm giving you the number. After the class, you can send a message so that I'll be adding your number and you can see the status and about the upcoming classes on Unacademy Plus. Okay, no problem. Chalo, let's start. Heat and work. So my dear students, whatever you are focusing, the study on which you wish to analyze, that we call it as system. Anything which you wish to analyze, we call it as system. And you know, basically we classify into closed system and open system. Some students may be saying, sir, there is isolated system also now. Isolated is a special case of closed system only. In closed system, there is only energy transfer. There is no mass transfer. In open system, there is energy transfer and there is mass transfer also. In isolated system, there is neither energy transfer nor there is mass transfer. Now you may be wondering, sir, thermodynamics is the science of energy transfer. That's why we don't study isolated systems. Only under references we'll be doing that. Are you getting, sirs? Are you getting? So therefore, closed system, only energy interaction, no mass interaction. For example, let us take a closed sealed container. Let me supply heat. So what is happening? There is an energy interaction, but there is no mass transfer. That's why closed systems are also known as control mass system, because the mass is fixed. And open systems, you know, my dear students, the most important part in open system is the mass is crossing the boundary. Let me tell you very clearly. Dekho ek baar. Take a second, please. Mass is crossing the boundary. Now you may be wondering, so for example, dekho, let us take a pipe and the fluid is flowing through this pipe. And if I take this as my system, that is, we call this as control volume. The open systems are analyzed by using control volume technique. What is control volume technique? Why do we need that control volume technique? The reason is, look at carefully, mass is entering, mass is leaving. So if you understand carefully, say same mass is entering, same mass is leaving, but there is no guarantee that every time the same mass is entering and same mass is leaving. There is no guarantee. Suppose same mass is entering and same mass is leaving. Same mass is entering, same mass is leaving. You may be saying, sir, already in this volume, control volume, say there is 100 units of mass. And let us say 10 units is entering and 10 units is leaving. So 100 plus 10 is 110. 110 may say 10 gaya, so again it is 100. So it is same na, sir. But please understand carefully. The identity of the mass is changing. What do we mean by identity of mass? It's not the same 100 kg mass. New mass is entering. It's something like this. In a classroom, there are 100 students. 10 students entered, 10 students left. But please note on that, new 10 are added, old 10 are leaving. So new composition of 100 is totally different. So identity is changing. That's why, please note on that. But in case of closed system, whatever you are doing on the same 100, neither the mass is entering nor leaving. That's why the identity is fixed there. Therefore, in closed system, we also call it as control mass system. In open system, as the identity is changing, so therefore what we do is we take some volume surrounding the device which we wish to analyze. So therefore, closed system and open system, closed system, control mass, open system, control volume. Excellent, no problem at all. And you know, there are some properties. What are properties? Any measurable characteristics, any measurable. For some time I will not see your charts, and let me cover in a very fast manner so that you will get some advantage over it. Properties are any measurable characteristics like pressure, temperature, volume, density. These are properties. Very good, no problem at all. Any measurable characteristic. All characteristics are not properties. All these I had explained in my regular classes, no problem at all. So what are the characteristics? Like properties ke kya features hote hai? They are point functions. They are exact differentials. What do you mean by exact differentials? For example, let us take pressure. Let us take volume here. So please understand carefully. Now, say I'm moving from point 1 to point 2 by this path. So the pressure at point 1 is say 10 units and pressure at point 2 is some 6 units. So what is the pressure difference between 1 and 2? It is 10 minus 6, that is 4. So let us take another path. So if that path is between same endpoints, even for this path, the pressure difference is exactly 6 minus 4. That's why we call it as exact differentials. All this I had explained very clearly, no problem. Properties are point functions. As long as this point is fixed, properties are fixed. When the point is changing, and this point is also, we call it as state of the system. When there is a process is nothing but change in state. So why the state is changing? Because of some energy interactions, maybe heat, maybe work, or so on and so. So therefore, now, even though paths are different, properties are point functions. Therefore, the property at point 1 is 10, property is at point 2 is 6. Whether you follow this path or this path, the change in property is 10. That's why we call it as exact differentials. No problem at all. And my dear students, our thermodynamics is, listen carefully, thermodynamics is based on some laws. And those laws are zeroth law, first law, second law, and third law. So zeroth law is basically a concept of temperature. So what is the statement of zeroth law? Straight away I'm going, because simple areas I will not go into much details. Straight away I'm revising things. Zeroth law. This law is giving us the concept of temperature. I repeat, this law is giving us the concept of temperature. What does it mean? When a body A is in thermal equilibrium with body B and body B is in thermal equilibrium with body C separately. What do I mean by that? Separately word is very, very important. What do I mean by separately? A is in contact with B, B is in contact with C, but there is no direct contact between A and C. So if A and B are in thermal equilibrium, I can say temperature of A is equal to temperature of B. If B and C are in thermal equilibrium, temperature of B is equal to temperature of C. So my zeroth law says if A and B are in thermal equilibrium, B and C are in thermal equilibrium, then A and C are in thermal equilibrium. So I gave you physically, beautifully, I explained everything in my classes, but now I'll not give all those details because it's not a regular class. Wonderful, sirs. No problem at all. No problem at all. Anything more? Leave it. So now there is one term known as thermometric property. See, all thermometers are based on thermometric principle. What is thermometric principle? There are some properties which vary with temperature. So directly we are not finding out temperature. We are finding out a property which is varying with temperature. So after finding that property, we'll find out temperature. The property which helps in finding the temperature, we call it as thermometric property. So we have got, I repeat, sirs, you cannot find temperature directly. So you will be finding a property which is depending on temperature, which is varying with temperature. So first I'll find out that property which varies with temperature. So with the help of that property, we find temperature. So it is an indirect method. So we have different types of thermometers. Resistance thermometer, then we have thermocouple, then we have constant volume gas thermometer, then we have constant pressure gas thermometer. Now let us see what is the property, thermometric property. In resistance thermometer, it is electrical resistance, and in thermocouple, it is EMF or voltage. First, we'll find out, my dear students, in resistance thermometer, we'll find out resistance. With the help of resistance, I find temperature. In thermocouple, we find EMF or voltage. With the help of voltage, we find temperature. In constant volume gas thermometer, we find pressure. With the help of pressure, we find temperature. In constant pressure gas thermometer, we find volume. With the help of volume, we find the, temperature. So sometimes there is a possibility of match the following questions. Sometimes there is a possibility of match the following questions. Now, what is a pure substance? A substance which is homogeneous in chemical composition and homogeneous in chemical aggregation is known as a pure substance. So please, my dear students, do not get confused. What is a pure substance? It has to be homogeneous in chemical composition, homogeneous in chemical aggregation. For example, let us take water and steam. What is the chemical formula of water? H2O. What is the chemical formula of steam? H2O. What is the composition? There are 2 atoms of hydrogen, 1 atom of oxygen. In steam, there are 2 atoms of hydrogen, 1 atom of oxygen. So if you see the composition, 2:1, 2:1, it is homogeneous, means same composition. But that doesn't guarantee you a pure substance. Now observe here. Now, what is chemical aggregation? It has to be homogeneous in chemical composition, homogeneous in chemical aggregation. Aggregation is nothing but bonding. For example, here 2 atoms of hydrogen are bonded to 1 atom of oxygen. Here 2 atoms of hydrogen are bonded to 1 atom of oxygen. In water, 2 atoms of hydrogen are bonded to 1 atom of oxygen. In steam, 2 atoms of hydrogen are bonded to 1 atom of oxygen. So therefore, bonding is also same. That is, not only 2:1 composition is same, but the aggregation is also same. Means bonding is also same. That's why we call it as a pure substance. For example, now one more important point that you need to note is phase has nothing to do with pure substance. What do we mean by that? So it is in gaseous phase, steam. Water is in liquid state. This phase is different, this phase is different. Even though phases are different, but it is a pure substance. So please note down that phase has nothing to do. A pure substance can exist in a single phase or can exist in more than one phase. Very good, sirs. So for example, if you take air, air is not a pure substance, but dry air is a pure substance. Why, sir? Parts which can be condensed and separated. For example, you have air. Whenever I say air, definitely there is a moisture. Now what you do is, let us say we have air. So in air, we have oxygen, nitrogen, hydrogen, water vapor. Now cool this air. When you cool this air, water vapor gets separated, condensed. So therefore, everywhere the composition is not same. So parts which can be separated on condensation are not treated as pure substances. And similarly, if you take dry air, so for example, in dry air, we have oxygen, nitrogen, and some other minor gases. So dry air can be treated as pure substance. Why? Because everywhere, if you take dry air, here oxygen, nitrogen is homogeneous. 23 oxygen, 77 nitrogen. Here also same, here also same, here also same. But now, if you have moist air, if you cool, it is completely water. If you cool, it is condensed water. But here we have oxygen, nitrogen, dry air. Here it is water vapor. It is not exactly same. So even though moist air is not a pure substance, but dry air is a pure substance. Is it clear, my dear students? Is it clear? Shall I proceed? Bolo re. Great. Now let's proceed, my dear students. Now have a look at this. You know, processes are, what is a process? Change of state. Processes are classified into like basic classification, reversible and irreversible. What is reversible? What is irreversible? Which is not reversible? Then what is reversible? Look at carefully. Look at carefully. My dear students, a process which has a characteristic of slowness and which has no friction, no dissipative effects. For example, carefully. Suno carefully. Now I have kept 100 units of weight here. There is a gas here. There are 100 units. I have kept 100 units of weight. Please understand carefully. Chalo. I have a gas and there is 100 units of weight. And suddenly I remove this weight. What will happen? When I remove this weight suddenly, the gas will expand suddenly. When it expands suddenly, can you trace intermediate points? Can you trace intermediate points? No, you cannot trace. So please note down that now you take small weights and ek weight nikalte jana. Just remove one weight. And you know, if you remove one weight, it just moves up and stops equilibrium. If you remove one more weight, it moves up and stops. It moves up, moves and stops. So every point is passing through equilibrium. And this is known as quasi-static process. So slowness is the characteristic of quasi-static. Quasi-static means very slow process. But please note down that quasi-static ka matlab kya hai? It may be reversible, it may not be reversible. If there is a friction, that is not reversible. So reversible hone ke liye, it should follow the same path as forward path. So agar ek process aisa ho raha 1 to 2, in reverse also, it should follow the same path without leaving any effect on system and surroundings. What do I mean by that? In forward process, if the system is giving 100 units of heat to surroundings, in reverse, it should give exactly the same. So whatever is occurring in forward, exactly the same thing should occur in backward. If you want that to happen, ek chota sa example de raha hu, sir. So for example, you are falling from first floor. You are falling from first floor. In the middle, can you reverse the direction? You cannot, because the gap is so large. But if you are falling, if you are coming through, say, ladder, सीढ़ी से आ रहा है, So one step you have taken. If you want to reverse easily, you can reverse. So therefore, if you want reversible to occur, it has to be very slow. Slowness is required for reversible. Apart from that, there should not be any friction. So frictionless quasi-static is the reversible process. In reversible process, whatever is occurring in forward, exactly the same thing is occurring in backward. And in examination, if nothing is given, we treat processes to, agar koi information nahi hai, and without that assumption, it is not possible to do, we assume that and will proceed. So reversible hone ke liye, slowness, quasi-static is must. So please note on that, all reversible processes are quasi-static. Reversible hone ke liye slow zaruri hai. But all quasi-static need not be reversible, because quasi-static mein agar friction hota hai, it cannot be reversible. All this I had explained in my classes very clearly. Now, dear students, energy interaction is of two types. One is heat interaction, other is work interaction. So what is work interaction? My dear students, work is said to be done by the system when the sole effect on things external to the system is raising of weights. इसका मतलब क्या है सर? इधर देखना. So when the effect is equal to raising of weights, मैं क्लास में बहुत अच्छी तरीके से बताया था. Look at, let us take, my dear students, a battery, and there is a motor, and this motor, say, is connected to a fan. Let us take, dear students, let us take this battery as our system. Let us take this battery as the system. So what is the definition of work? Work is said to be done by the system when anything external is equated to raising of weights. But please note on that weights may be raised or may not be raised. सर समझ में नहीं आया, नहीं आएगा सर, क्योंकि आप रिवाइज करके आए तो समझ में आएगा. This is not preliminary class. It is not a basic class. Look at carefully. Now, what do I mean by that? The battery is running the motor, and motor is running the shaft, and shaft is rotating the fan. Are the weights raised here? No. I told you very clearly, iska equivalent diagram dekhenge. Let's see the equivalent diagram. Dear students, let us see the equivalent diagram. So I am not touching the system. My system is battery here. Dear students, yahan pe bhi my system is battery. So I'm just replacing this motor with a pulley and weight. What is happening? You tell me. Kuch nahi kar raha hu, sir. I'm not touching the system. Here also my system is battery. Here also the system is battery only. So what did I say? Work is said to be done by the system. Here battery the system. When the sole effect is raising of weights external to the system. Weights must be raised external to the system. For example, look at carefully. Now battery is running motor. Motor is rotating the shaft, and shaft is raising the weights. Where are weights raised? They are raised out of the battery, external to the battery. So work is done by the system. And don't just see ki ye alag, ye alag. No sir, both are exactly the same. Both are exactly the same. But I have just equated it. I never said always weights are to be raised. It should have the capacity to raise the weight. Wait, is it clear, sir? Is it clear? Is it clear? Clear. Wonderful, sirs. ये हो गया. Now, एक काम करेंगे, sirs. Such questions can also be asked. Let us take this as the system. Let us not waste time, sir. Let us take this as the system. Battery, motor, and this pulley or fan. ये complete को system लिए. What is our work? Can anyone tell what is the work? What is the work? फटाफट बोलो, sirs. If I take complete as the system, what is the work? No one is giving answers. No one is giving answer. Bolo. Zero work. Very good. Zero work. Why? Weights must be raised external to the system. Look at my dear students. मैं बात कर रहा हूं, आप सुन रहे हैं. So if this is the boundary of the system, that's why work should cross the boundary. That's why we call work as a boundary phenomenon. इधर देखो. This is the boundary. So work is crossing the boundary. System के बाहर, boundary के बाहर weights raise हो रहा है. So I'm talking, if this is the boundary, when I'm talking, my voice is crossing the boundary. That's why you could listen. Now if I talk and देखो, I'm talking but everything is inside. Therefore, you cannot hear. So when something is done internally, you will not feel work. You will not feel work. So therefore, it is a boundary phenomenon. It should cross the boundary. It should cross the boundary. Is it clear, my dear students? Now, leave it. फटाफट करेंगे sir. Leave it. No problem. Now, my dear students, first we'll go to work in a closed system. Work in a closed system. The closed system work is given by integral PDV. But be careful, sirs. This work has some limitations. It should be applied only for a closed system. And it should be applied only for a reversible process. If the process is not reversible, this equation is not valid. PdV is applicable only for reversible. इसका मतलब ये भी कर सकते हैं, अगर आप प्रेशर यहाँ पे वॉल्यूम है, if there is a process, listen carefully, if there is a process and you know, if I project it, अगर यहाँ का प्रेशर P है और वॉल्यूम dV है, this area is giving me closed system work. So always remember that if you want closed system work, you have to project the curve on volume axis. That will give me closed system work. No, it will give me closed system reversible work. Closed system reversible work. For example, he may be asking you what is the work done here. Kuch mat karna. This is the starting point. This is the final point. Please note down that if it is an open system, this is wrong. It is for closed system. Project it, find out the area under the curve. If this is the process, project it. It is PV diagram. Project it, and this is my work. Just find out. Project the process on volume axis, and what is the area under the curve, under the process, you find out. That will give me what? Closed system reversible work. And now you may be asking question, sir, what if the process is irreversible? Wait, when I teach you first of thermodynamics, then I think you know the equation. D dash Q is equal to dE plus D dash W. I'll be using this equation for calculating. This is applicable, don't worry. This is the first law equation. This is applicable for reversible, irreversible, anything. So if you want to calculate for any process, maybe reversible, maybe irreversible, go for this. So from this, I can calculate the work. Don't worry at all. Now, let's see, there are different processes, my dear students, different processes. So, yaad rakhna, closed system work is integral PdV. So, let us take constant volume work. So, 1 second dekho idhar. There is a piston cylinder arrangement. Now, I am closing it with stops. Let me supply heat. What is happening to the volume of the system? So, you know, the piston is held at its place with the help of stops. So when you are supplying heat, the piston can neither move up nor down because these stops are preventing the movement of the piston. The movement of the piston. That's why whatever the volume is there, it is constant. Now you tell me, what is the work done? What is the work done? For work, it should be in a position to raise the weights externally. Where are the weights raised? So whatever you are supplying, whatever the heat you are supplying, everything is stored in the system. Everything is stored in the system. No external work. So therefore, constant volume closed system work is equal to 0. Constant volume closed system work is equal to 0. Is it clear, my dear students? Leave it. Now, यहाँ पे एक twist है, sir. Is the constant volume work closed system work always 0? Always. देखो, work is given by PdV. Is the constant volume closed system work always 0? My dear students, is the constant volume closed system work always 0? देखो एक बार बताता हूं. What is the volume here? It is a constant volume. So constant volume के लिए change in volume is 0. So 0 into P is 0. So work is 0. But you have to be a bit cautious. Let me explain. Let us take a system. This is the system. Now there is a paddle wheel. There is a paddle wheel. There is a wheel. Now with the help of this rope, and there is a pulley here. Now weights are lowered. Where are weights lowered? If this is my system, my dear students, अगर ये system है आपका, if this is the system, where are weights lowered? Raising of weights is nothing but work done by the system. Here weights are not raised, weights are lowered. Means work is transferred to the system, work is given to the system. One more thing. Generally we follow one convention. What is that convention? Work done by the system is positive. Work done on the system is negative. Whenever the system is doing work, so it is raising weights, means expansion. Closed system की बात चल रही sir. Now, first we'll complete closed system. And similarly, is it okay? बोलो रे. Now, similarly, whenever ध्यान से सुनो sir. Now, यहाँ पे वर्क हो रहा है या नहीं? So it is a rigid container, dear students. My dear students, it is a rigid container. So whatever the gas is there inside or whatever the fluid is there, its volume is not changing. Definitely it is a constant volume process. But still here the work is not 0. It is actually negative. What is negative? Work is done on the system. That is the convention. That is the convention. That is the convention. Can you justify? Sir, PdV to 0 hai yahan pe. PdV is 0, but work is not 0. What is the reason for this? My dear students, PdV should be applied. Can you give an example where PdV is 0, but work is not 0? He may be asking in examination, can you give an example where PdV is 0, but work is not 0? यहाँ पे वॉल्यूम इज कांस्टेंट, तो चेंज इन वॉल्यूम इज जीरो, तो पीडीवी इज जीरो बट वर्क इज नॉट जीरो. व्हाट इज द रीजन? तो आप बोलेंगे सर वर्क इज पीडीवी, but you are saying PDV is zero. When PDV is zero, work should be zero. But you are saying PDV is zero, but work is not zero. You are contradicting your own statement. I told you very clearly, PDV, work is equal to PDV must be applied only when the process is reversible. Is this process reversible? देखो यहाँ पे जब wheel घूम रहा है, when the shaft is rotating, there is a friction at the contacting points. So thereby, and there is a fluid friction also. So whenever there is a friction, how can it be reversible? It is irreversible. So whenever it is irreversible, so paddle wheel work is irreversible. So I cannot apply PDV. So I cannot apply PDV. Therefore, you can use this equation. So how to find out? This equation cannot be used. What is the reason for that? Because PDV must be used only for reversible. But paddle wheel, so जब shaft घूम रहा है, there is a friction. Whenever there is a friction, how can it be reversible? It's not reversible. So you will not get an idea of PDV. So don't equate work is equal to PDV if the process is irreversible. So if it is irreversible, PDV का कोई लेना देना नहीं है. Whenever the process is irreversible, PDV is not giving. PDV क्या है मुझे पता नहीं सर. Don't equate that to work. Is it clear? Dear students, is it clear? So please note on that. Most of the constant volume works are zero. Except paddle wheel work. Except paddle wheel work. So please note down that always he may be giving you one statement. Statement 1. Closed system constant volume work is always zero. Second statement. Closed system constant volume work is always zero. Second statement. PDV is zero in a paddle wheel is running in a rigid container. In a rigid container, a paddle wheel is running. PDV is zero. Which statement is correct? Look at sirs. In a rigid container, volume is constant. Second statement is correct. So when volume is constant, PDV is zero. That is also correct. But he is not saying PDV as work. So second statement is correct. So what is the first statement? Constant volume closed system work is always zero. That is not correct, sirs. Constant volume closed system. If this is the special case. When there is a paddle wheel, weights are lowered, means work is transferred to the system, so work is not zero. Is it clear, my dear students? Is it clear, my dear students? Wonderful students of India. Now, you have seen this one, constant volume. Let's go to constant pressure. This constant volume is also known as isochoric. Yes or no? Constant volume process is also known as isochoric process. Isochoric, chor nahi hai. Isochoric process or isometric process. In examination, suddenly the word comes. A gas is undergoing isometric process. A gas is undergoing isochoric process. It means constant volume process. So except paddle wheel work, all constant volume works are zero. समझ में आया सर? I'm talking about closed system. I'm talking about closed system. Is it okay? सब लोग जिंदा है रे? बहुत लोग हैं. जिंदा है? Wonderful, sirs. Wonderful. Let's go to constant pressure, sirs. बहुत important है. ये आने का chance है, sir. Generally, such questions can be linked to spring. Such questions can be linked to spring. ये करेंगे, sirs. There is a piston cylinder arrangement. Now, there is a gas inside the piston cylinder arrangement. Look at carefully. Now, I am heating the gas. And please note down that the piston is moving at a uniform velocity. मान लो, the piston is moving at a constant velocity. At a constant velocity. Whenever it is moving at a constant velocity, what is the acceleration? Zero. So therefore, the net external force is equal to mass into acceleration. When the piston is moving at a constant velocity, so change in velocity is zero. So acceleration is equal to rate of change of velocity, that is zero. So acceleration zero है, तो net external force is zero. It means it is in dynamic equilibrium. तो अब क्या होगा सर? देखो carefully. Net external is zero. Observe carefully. Now let us try to draw the free body diagram of this piston. Look at carefully. What is happening? Outside there is atmospheric air. So atmospheric air will exert a pressure. Wonderful, sirs. If the area of the piston is, देखो piston का area, it's like this. Look at, this is the piston. This is the piston, and this is the area, circular area. If the area of the piston is A, this is the force, the atmospheric force acting on the piston, and you know its weight is also acting in downward direction. No problem at all. No problem at all. Now, उसके बाद अंदर गैस है, what will happen? So external atmospheric pressure is pushing it. This is the area of the piston. Atmospheric pressure is pushing it down. So area into pressure is the force exerted by atmosphere. Its weight is downwards, and inside there is a gas. Gas will exert in upward direction. So therefore, this is gas, but it is wrong, sir. How can I equate pressure to force? So it is acting. The bottom area, top area of the piston is same. So into area. Now it is in dynamic equilibrium. So therefore, assume that the piston is moving at a uniform velocity. In the examination, if nothing is mentioned, piston is, he will not say piston is moving at a uniform. You assume it. Generally, it is assumed. लेकिन आईसी इंजन्स में नहीं होता सर. आईसी इंजन्स में पिस्टन जब when there is a combustion, it pushes with high force. It doesn't move with a constant velocity. So there the pressure is not constant. Please understand these points carefully. Please बताइए, are we clear, my dear students? There it is not constant. Understand these points carefully. So therefore, now dynamic equilibrium के लिए apply करना, net external force is 0. Sum of the downward is equal to sum of the upward, or sum of the downward minus upward should be 0. So or upward minus downward is 0, or upward is equal to downward. So PATMA downward plus weight is downward should be equal to P gas into A. Absolutely fine. So I divide both sides with area. What do I get? If I divide with area, PATM plus W by A is equal to P gas. I have divided with area. ध्यान से सुनो सर. Is the atmospheric pressure changing? No. Who has given you authority to change the atmospheric pressure? It is constant. Is it changing? No. Is the weight of the piston changing? It is just traveling in either upward or downward direction. So is the weight of the piston changing? No. Is the area of the piston changing? वो तो same area है, same piston is moving upwards or downwards. This is also not changing. When all are fixed, my gas pressure is also fixed. Means even though the piston is moving, reciprocating, so it is all are fixed. So therefore gas pressure is constant, my dear students. So it is an example of constant pressure. But mind you, here the piston is assumed to be moving at a constant velocity. बोलो रे बाबा, ठोको ताली. नहीं यार, अरे कैसे मर जाएंगे आप. क्लियर? चलो अब देखो, लेट्स ट्राई टू फाइंड आउट द कांस्टेंट प्रेशर. ऐसे क्वेश्चन ही आएंगे सर, इट इज कनेक्टेड टू अ स्प्रिंग, समथिंग लाइक दिस. Such questions will come, so be careful, be careful. Okay, no problem at all. Now let's go to constant pressure process and look at बहुत important point बता रहा हूं sir. What is work integral PdV? Is it a closed system or open system? First we'll deal with closed system. पूरे closed system को ही ले लेंगे. So therefore, how do I show constant pressure? Like this. Like this. Okay, no problem. So it can be to the right or it can be to the left, depending on that heat transfer. देखो एक बार ध्यान से सुनो सर. Let us assume that in a piston cylinder arrangement, I am taking an ideal gas. What is an ideal gas? A gas in which there are no intermolecular forces, which obeys our gas laws. So for ideal gas, I can use PV is equal to MRT. And you should be very, very careful, sir. Exam में आपको confuse करेगा. He will give you gauge pressure. He will give you temperature in centigrade. Always remember, whenever you are using ideal gas equation, this pressure should be in absolute scale. Confuse करने के लिए the gauge pressure of the gas is so and so बोलेगा. So absolute is equal to gauge plus atmospheric. First convert that gauge pressure into atmospheric, then convert from centigrade to Kelvin. तो और एक बात. So how do I convert? So Kelvin is equal to degree centigrade plus 273.15. And you know, the triple point of water is arbitrarily taken as 0.01 degree centigrade. What is triple point? It is the state at which all the three phases exist. What are those three phases? Solids, ice, water, and water vapor. So triple point of water is 0.01 degree centigrade. If you want the same temperature in Kelvin, करो 0.01 plus 273.15, तो कितना आएगा सर? 273.16 Kelvin. Please बताइए, are we clear? क्या ये स्पीड ठीक है सर? क्या ये स्पीड ठीक है? चले कंटिन्यू, बोलो फटाफट बोलो. क्या ये स्पीड ठीक है? This class is not meant for those students who are studying for the first time. This is for those students who have completed their course and they have come for revision. Is it okay? So ऐसे ही करेंगे. चलो कोई दिक्कत नहीं. Thank you my dear students. देखो now apply करो. So work is equal to constant pressure work. Pressure is constant, उसको बाहर ले लेना, integral dV. Let the volume be varying from initial volume to final volume. So W is equal to P into V final minus V initial. इधर देखना sirs, इधर देखना. Nothing sirs, इधर देखो. This is the initial point, this is the final point. This is the initial point, this is the final point. Project it, you find out this area. This is initial volume and this is the final volume. This is Vf minus Vi and this is the pressure, whether it is P1 or P2, everything is same. And that area will give me closed system constant pressure work. Now, I'll ask you one question, please answer. So, my dear students, I have a question, sirs. I have a question. Answer karo. The question is, बहुत ध्यान से सुनो, sirs. Let this be the initial point. Let this be the final point. Let the process, is it a constant pressure process? Yes, sir. And let the pressure be P. Whether it is initial or final, it is moving like this. It is moving along the same pressure, same pressure, initial, final. So project karo, to Vi, project karo, to Vf, and that is giving me work. But you know very well, work is equal to integral PdV or area under the curve, area under PV diagram. This is giving me work. So isko kya likhenge? Length into width, that is Vf minus Va. But dekho, sirs, this is applicable for reversible because PdV is applicable for reversible. Now, dear students, for constant pressure process, the same equation can also be used for irreversible. तो आप बोलेंगे सर ये कैसा है? सुनो, ये नहीं बोल रहा कि reversible work, irreversible work same होगा. I never said. Equations are same. Even for irreversible constant pressure process, the work equation is same. But works are not same. सर नहीं समझ में आया सर. मैं ये बोल रहा हूं सर, let us take two systems, both are undergoing constant pressure processes, दोनों में same heat supply करना. If it is reversible, ये कुछ वर्क देगा, if it is irreversible, ये भी वर्क देगा. दोनों के लिए इक्वेशन तो सेम है, लेकिन value of work is not same because the final state is not same, even because of friction. देखो ध्यान से सुनो सर, look at carefully. मैं एक छोटा एग्जांपल दे रहा हूं सर, इधर देखो, please listen carefully, please listen carefully. Now let this be the initial volume. Now I am supplying heat. Let this be the final volume. Okay. Now I want to calculate work. You tell me how much distance it has moved. How much distance it has moved. Let us say it is x distance. Can I write this as, if the area of the piston is A, so what is A into x, sir? Area is A into length. What is area into length? This, देखो, area of the piston is A into x, means you are finding out this volume. What is that volume? It is Vf minus Vi. नहीं आ रहा सर समझ में, फिर से बता रहा हूं सर, सुनो. Let me explain again. This is the initial position. So this is the initial volume. Let us say I am supplying heat. So the piston has moved from this position to this position. Let this be the final volume. What is this, sir? Anyone? What is this volume? It is the change in volume. It is the change in volume. That is Vf minus Va. But the volume can also be written as, I want this volume. What is that volume? Area of the piston into how much distance it has moved, x. So area into x. Exactly. No problem at all. Look at carefully. Look at carefully. Dear students, if the atmospheric pressure is P atm, let us say, this is weightless, जो भी है, how much work it has done? बहुत simply, sir. What is the force atmospheric pressure is exerting into area? Now you tell me what is the work to overcome this resistance. This force, we are moving to what distance? X. So you tell me whether it is reversible or irreversible. What is work? Force into displacement. देखो, force तो P atm A है into A into distance कितना है? X हो गया. But what is A into X? What is A into X? That is Vf minus Va. So Vf minus Va. इसका मतलब constant pressure के लिए, अगर pressure constant है, you will get the same equation. But please note down that एक logic बता रहा हूं सर, equation तो same है, लेकिन in reversible process, if it is expansion, you will get more work, even though equations are same. But in reversible, you will get more work. In irreversible, I am not saying reversible work is irreversible. I never said that. I said equation is same. फ्रिक्शन के अगर देखो, अगर यहां पे पिस्टन सिलेंडर है, अगर यहां पे पिस्टन सिलेंडर है, कांस्टेंट प्रेशर, यहां पे मान लो फ्रिक्शन है, तो इट इज अ कांस्टेंट प्रेशर, दिस आल्सो कांस्टेंट प्रेशर. तो यहां पे इनिशियल स्टेट सेम है, अगर सेम हीट सप्लाई कर रहा है तो इसमें ज्यादा मूव करेगा और मुझे वर्क ज्यादा मिलेगा इसमें. लेकिन इक्वेशन क्या यूज किए? P इंटू Vf माइनस Vi. इसमें भी सेम इक्वेशन यूज करता हूं, लेकिन द फाइनल स्टेट इज नॉट, बिकॉज ऑफ फ्रिक्शन इट इज नॉट मूविंग टू दैट, इवन दो द इक्वेशन इज सेम, द फाइनल स्टेट इज नॉट सेम. सो वर्क मुझे मान लो 8 मिल रहा है, इवन दो इक्वेशंस आर सेम, द वर्क इज नॉट सेम. सो कांस्टेंट प्रेशर के लिए P इंटू V2 माइनस V1 इज एप्लीकेबल वेदर इट इज रिवर्सिबल और इरिवर्सिबल. सो ओनली डिफरेंस इज रिवर्सिबल विल गिव मी, इक्वेशन सेम है सर, लेकिन values are not same. So whether it is constant pressure, reversible, constant pressure, irreversible, P into V2 minus V1 I will apply. But reversible will give me more value, irreversible will give me less value. If the initial states are same, final states are not same, because friction के कारण वो ज्यादा expand नहीं होगा, resistance के कारण. अगर same heat supply कर रहे हैं तो reversible will have more expansion, irreversible will have less expansion. तो दोनों equation same. तो as VF is less in irreversible, that's why you get less work. Is the concept clear, sirs? Is the concept clear? Is the concept clear? Is the concept clear, dear students? Only Rahul is saying, Sarthak, फटाफट, Aryan. Okay, Lalit Babu Lalit re, Himanshu Jaiswal, Sayandev आ गए. चलो, leave it. तो constant pressure work तो हम कैलकुलेट किए, अब आएंगे isothermal. And dear students, look at carefully. What is isothermal? Temperature is constant. एक छोटा सा एग्जांपल दूंगा सर. Dear students, अच्छा सुनो, एक एग्जांपल दे रहा हूं सर. Yes, exactly. Rohit Sri Sai, exactly. Even though the equation is same, now isothermal constant temperature. एक बार मैं characteristic बताऊंगा सर. First, I'll tell you the characteristic of isothermal. Slowness is the characteristic of isothermal. इधर देखो, मैं हाथ रब कर रहा हूं, देखो. फास्ट रब करूंगा, टेम्परेचर बढ़ गया. देखो, टेम्परेचर इज चेंजिंग. Whenever the temperature is changing, is it isothermal? No. अब देखो एक बार. स्लो कर रहा हूं. What is the temperature? Slow कर रहा हूं. What is the temperature? Same. Same temperature means isothermal. So whenever you want isothermal, the process has to be very slow. The process has to be very, very slow. Is it clear? So isothermal होने के लिए, the process has to be very slow. Now, देखो, let us take an ideal gas. And now you know the equation of ideal gas, that is PV is equal to mRT. Look at carefully. We are dealing with closed system. In closed system, what is constant? Mass is constant. R is characteristic gas constant. Do not get confused between characteristic gas constant and universal gas constant. ध्यान से सुनो. Number of moles is equal to mass by molecular mass. At least you know this now. Number of moles is equal to mass by molecular mass. So I will write mass as number of moles into molecular mass. So can we write this equation as PV is equal to M? What is M? N capital M. M को क्या लिखेंगे? N capital M RT. ध्यान से सुनो सर. This M into R, we call it as universal gas constant. So if you want characteristic gas constant, it is universal gas constant by molecular mass. Be careful, my dear students. Be careful. So I will write the ideal gas equation also as what is M into R? What is M into R? R bar. So therefore it is R bar T. So ideal gas equation can be written in two forms. One is PV is equal to mRT. The other is PV is equal to N R bar T. ध्यान से सुनो sirs. Whenever it is characteristic gas constant, it is mass. Whenever it is universal gas constant, it is number of moles. Look at carefully. Now, what is the unit of characteristic gas constant? It is kilojoule per kg per Kelvin. Is it okay? Now, what is the unit of R bar? It is kilojoule per kilomole Kelvin. And what is the value of R? Confuse mat hona sir. There was one question which was very beautifully crafted in one of the examinations. What is the value of R bar? I am writing this as 8.314 kilojoule per kilomole Kelvin. और एक बात है sir. It can also be written as 8.314 joule per mole per Kelvin. क्या ये? Which one is correct? First one or second one? Which one is correct? First one or second one? आप बताइए sir. Which one is correct? First one or second one? Which one is correct? First one or second? Wonderful, my dear sir. वाह, क्या students है रे बाबा. Both are correct because यहां पे किलो है, यहां पे भी किलो है. किलो कट जाएगा. 10 power 3 कट जाएगा. तो जूल पर मोल पर केल्विन. So both are correct. Both are correct, sirs. It is 8.314 kilojoule per kilomole per Kelvin, और 8.314 किलो किलो को काट डालना. So if you cut this, it will be joule per mole per Kelvin. Be careful, my dear students. You should be very cautious. Simple things are always complicated. Is it okay? Right. अब देखो सर, the ideal gas equation can be written in two forms. One is PV is equal to MRT. The other is PV is equal to NR bar T. No issues. Chemical engineering students predominantly they use this, but we mechanical engineering students we use chemical engineering students generally they use in number of moles. Don't worry, so I have given you both, don't worry at all. Chalo ye lete hain sir. Now observe here, please my dear students, observe here. It is a closed system, mass is constant. For a particular gas, R is constant. Now isothermal, temperature is constant. So PV is equal to constant into constant into constant is a new constant. Whenever PV is constant, we call this as, if you take on PV diagram, something like this, my dear students. If it is X and it is Y, if XY is constant, we call it as rectangular hyperbola. So here, in place of Y, we have P. In place of X, we have V. So it's something like XY is constant. Therefore, it is a rectangular hyperbola. Rectangular hyperbola. So please note down that isothermal process for an ideal gas on PV diagram follows rectangular hyperbola. Ab dekho, some questions may come in examination, something like this, like this, like this, like this. All these are isotherms. It is a rectangular hyperbola. Let us say this is T1, let us say this is T2, let us say this is T3. Now you tell me, he may be asking in examination the increasing order or decreasing order of temperature. कौन सा temperature ज़्यादा है बोलो sirs? बोलो कौन सा टेम्परेचर ज्यादा है, एक बार बोलो. नाउ सिंपल लाल ले लेंगे, ये वाला रंग ले लेंगे. देखो एक काम करो, let this be 0.3, let this be 0.2, let this be 0.1. look at carefully. वाह वाह, बहुत अच्छे स्टूडेंट्स है रे, अच्छे स्टूडेंट्स मिल रहे मुझे. देखो, what is the pressure at 2, 3, 1? Can I say P3 is equal to P2 is equal to P1? All are on the same pressure line, same horizontal. This is our V3. This is our V2. This is our V1. You know that for a given mass, ध्यान से सुनो sirs, please listen, ध्यान से सुनो, for a given gas, for a given mass, here mass is constant. Same mass, same gas are taken under different conditions. वो condition दिया है sir. Same mass, same gas. तो देखो PV is equal to MRT. Wonderful sirs. Look at carefully. तो mass is constant, R is. तो PV is directly proportional to what? T. देखो ध्यान से सुनो. Of course, on this temperature is constant. ध्यान से सुनो sirs. Look at everywhere what is constant, whether it is 0.3 or 0.2 or 0.1. ये सिस्टम के लिए, ये सिस्टम के लिए, ये सिस्टम के लिए, तीनों के लिए क्या कांस्टेंट है? ऑन द सेम हॉरिजॉन्टल लाइन प्रेशर इज कांस्टेंट, वॉल्यूम इज डायरेक्टली प्रोपोर्शनल टेम्परेचर. जब वॉल्यूम ज्यादा है तो टेम्परेचर ज्यादा होगा. किसका वॉल्यूम ज्यादा है सर? V1 और V2 और V3. When you are going to the right, the volume is increasing. V1 is more compared to V2 and V2 is more compared to V3. So obviously when V1 is more, T1 is more. So can I write T1 is greater than T2 greater than T3? लिख सकता हूं या नहीं रे? बोलो रे, बोलो बाबा, क्या हो रहा है? ओके उत्कर्ष, ठीक है. इज इट ओके? जो हो रहा है उसको एंजॉय करो सर्स, जो हो रहा है उसको एंजॉय करो, बिकॉज फ्रॉम 5th onwards I should be ready for plus classes, because on unacademy plus I am taking more subjects. So on 5th I have to be, from 5th I have to be fit. So therefore for 2 days I have some medical emergency, I'll attend that, and from 5th we'll start new courses happily. चलो ओके ना? जो हो रहा है वो देखो सर. on unacademy plus various educators have covered various courses. समझ गए ना? Continuously, Gill sir, Mondal sir, Rajiv sir, continuously they are taking classes. तो जो हो रहा है उसको एंजॉय करो सर्स. चलो leave it now. अब ये करेंगे. Now what is the equation for isothermal work? Work is equal to integral PdV. And you know, for isothermal process, of course, PV is MRT. M is constant, R is constant, T is constant, PV is constant. So can I write P as C by V? So यहाँ पे put करना और integrate करना. You will get work as MRT ln V2 by V1 or NR bar T ln V2 by V1 or P1 V1 ln V2 by V1 or P2 V2 ln V2 by V1. All are same. Why? Because PV is equal to MRT. M is constant, R is constant, T is constant. So P1 V1 is equal to MRT or P2 V2 is also MRT, but MRT is also equal to NR bar T. All are the equations. और एक बात है sir, P1 V1 is equal to P2 V2. Therefore, V2 by V1 can be written as P1 by P2. यहाँ पे I can replace P2 by P1 as V1 by V2. और एक बात बता रहा हूँ sir, you should be in a position to manipulate and improvise. क्वेश्चन को देखकर आपको पैटर्न चेंज करना पड़ेगा. Blindly do not by heart equations. Is it okay sir जी? बोलो sirs. Is it okay? Leave it. और एक बात है सर, और एक बात है, बहुत केयरफुली देखना सर. Can you tell me conditions for applying these equations? Can you tell me conditions for applying these equations? It has to be isothermal. It has to be a closed system. It has to be an ideal gas because I have used this, and it has to be reversible. Because we have used PDV. PDV is valid for closed system reversible. So closed system reversible. I have used PV is equal to constant, means isothermal. I have used P is equal to MRT, मतलब क्या है? Isothermal ideal gas. So what are the four conditions for applying this equation? It has to be isothermal, it has to be ideal gas, it has to be reversible, and it has to be closed system. Please बताइए, are we clear? और एक बात है सर, यहीं पे निपटा देंगे, यहीं पे. अब देखो सर, क्लोज्ड सिस्टम के लिए let us take PV. Look at carefully. My dear students, work is equal to integral PdV. This is applicable for closed system. And work is equal to minus VdP. This is applicable for open system. Now you may be asking where from you got. Can you tell me assumptions for this? ये बहुत important है sir. Already you know the process has to be reversible. Already a reversible closed system के लिए इसके लिए assumptions देखो. The assumptions are kinetic energy and potential energy changes are neglected. I'm talking about this equation, are neglected. Assumptions are very important. I have derived this equation. Second, process must be reversible. These are the things. इसको अप्लाई करने के लिए और एक बात है सर, if you want open system work, you have to project it on pressure axis. इस कर्व के नीचे का area, this will give me open system reversible work. And if you are projecting on volume axis, this will give me closed system reversible work. Both are for reversible only. If he is asking you to calculate irreversible work, on PV diagram, it will not give irreversible work. Whether it is open or closed system, केवल reversible के लिए ही मिलेगा. Is it okay, my dear students? बहुत अच्छे स्टूडेंट्स है रे, बहुत अच्छे स्टूडेंट्स है. अब देखो, आइसोथर्मल का एक खासियत है सर. व्हाट इज दैट? इसको जरा 90 डिग्री टर्न करना. यू जस्ट टर्न दिस 90 डिग्री. यही आएगा सर. क्यों सर? Because rectangular hyperbola is symmetric about x and y axis. So what do you mean by symmetric about x and y axis? अगर देखो, x y is equal to constant. x को y करना, y को x करना. x के प्लेस में y लिखना, y के प्लेस में x लिखना. Is it not the same? For example, what do I mean by symmetric? For example, there is a curve. x cube y is equal to constant. Is it symmetric? No. कैसे? x को y करो तो क्या होगा सर? x के प्लेस में y करो तो y cube. y के प्लेस में x करो. Are these two equations same? Absolutely no, sirs. But rectangular hyperbola, whether I write in place of x I write y, in place of y I write x, whether it is xy, whether it is 6 into 2 or 2 into 6, it is absolutely same. ये क्वेश्चन आ सकता सर. देखो, what is that assertion and reasoning question? ये आ सकता है सर. देखो, assertion or statement 1, statement 2. When an ideal gas undergoes isothermal process, statement 1. When an ideal gas undergoes isothermal process, open system and closed system works are same. Second statement or reasoning statement. Isothermal process for an ideal gas is represented by rectangular hyperbola, which is symmetric about both x and y axis. What is your answer? What is your answer, sirs? What is your answers? Answer. Both are correct. And it is the correct explanation. आ रहा है? जिंदा है लोग? लोग जिंदा है या मर गए? लोग जिंदा है या मर गए? वेरी गुड सर, वेरी गुड, एक्सलेंट स्टूडेंट्स ऑफ इंडिया, एक्सलेंट, वंडरफुल स्टूडेंट्स, ऐसा चाहिए, वाह, बहुत अच्छे स्टूडेंट्स हैं रे आप, गॉड ब्लेस यू एंड कम आउट विथ फ्लाइंग कलर्स। देखो और एक बात है, हाँ ओके, लीव इट, लीव इट, लीव इट। मैकेनिक्स में तो आप इमोशनल हो जा रहे हैं हर रोज क्लासेस को देखकर, लीव इट, ये हो गया, यहां तक किसी को कोई प्रॉब्लम नहीं है, नहीं है। और देखो आइसोथर्मल प्रोसेस में even though the temperature is constant, that doesn't mean, even though the temperature is constant, that doesn't mean there is no heat transfer. गलत है सर, इधर देखो, I will show you. There are small weights. ध्यान से सुनो, एक वेट को निकाल दिए तो क्या होगा सर? When one weight is removed, the gas will expand. It means my gas is raising weights. ध्यान से सुनो सर, there are so many weights put on the piston. So if one weight is removed, now this gas will push the piston up. Means gas is doing work. Means from its internal energy, it is doing work. So system is losing internal energy and doing work. So internal energy of an ideal gas is a function of temperature. It is known as Joule's law. What is Joule's law? Internal energy of an ideal gas is a function of temperature. तो जब गैस पिस्टन को रेस कर रहा है तो वर्क हो रहा है सर, तो गैस इज लूजिंग इट्स एनर्जी, सो टेम्परेचर इज डिक्रीजिंग। हाउ कैन इट बी आइसोथर्मल? सो इसीलिए आइसोथर्मल होने के लिए, सो व्हेन द वेट इज रिमूव्ड, व्हेन वेट इज रिमूव्ड, द गैस इज एक्सपैंडिंग, व्हेन द गैस इज एक्सपैंडिंग, it is doing work, its temperature is dropping, but I am not allowing the temperature to drop by supplying heat, so that जितना गैस वर्क कर रहा है तो टेम्परेचर घट रहा है, तो टेम्परेचर इज डिक्रीजिंग, सो वी आर नॉट अलाउिंग द ड्रॉप इन टेम्परेचर बाय सप्लाइंग हीट। सो रिमूविंग वेट एंड सप्लाइंग हीट इज एन एग्जांपल ऑफ आइसोथर्मल प्रोसेस। इसका मतलब कांस्टेंट टेम्परेचर होने के लिए, सुनो रे केयरफुली, सुनो केयरफुली, इट्स समथिंग लाइक दिस। मैं किसी को 100 रुपए दे रहा हूं, मेरे पास 1000 रुपए है, आई हैव 1000 रुपीज, आई हैव 1000 रुपीज। आइसोथर्मल का मतलब वो 1000 सेम होना है, सो आई एम गिविंग 100 टू समवन, तो 900 हो गया। हाउ कैन इट बी 1000? नो, सो समवन इज सप्लाइंग, सो 100 इधर आ रहा है, 100 उधर जा रहा है, हीट सप्लाई वर्क आउटपुट, हीट सप्लाई वर्क आउटपुट। तो एक क्वेश्चन आ सकता सर, इन विच प्रोसेस फॉर अ गिवन हीट इनपुट, शब्द को केयरफुली देखना, in which process for a given heat input maximum work is obtained? It is isothermal process, क्योंकि isothermal process में जो भी हीट आ रहा है वो पूरा वर्क में कन्वर्ट हो रहा है, बट अदर प्रोसेस में नहीं हो रहा है। इन अदर प्रोसेस सम इज स्टोर्ड एज इंटरनल एनर्जी। तो यहां पे शब्द यूज किया गिवन हीट इनपुट, सो वॉट एवर द हीट इज कमिंग, सो प्लीज लुक एट, आप कंफ्यूज हो जाएंगे, हाउ कैन कंप्लीट हीट बी कन्वर्टेड इनटू वर्क? अरे नमूने, complete heat can be converted into work in a process but not for a cycle. एक वर्ड इंपॉर्टेंट है सर थर्मोडायनेमिक्स में, तो इन आइसोथर्मल प्रोसेस यू कैन कन्वर्ट कंप्लीट हीट इनटू कंप्लीट वर्क। तो शब्द देखो, वर्ड्स देखो, फॉर अ गिवन हीट इनपुट, एक पर्टिकुलर हीट इनपुट के लिए किस प्रोसेस में मैक्सिमम वर्क मिलता है आपको? केवल आइसोथर्मल में मिलता है, क्योंकि देखो वहां पे ही यूज्ड द वर्ड गिवन हीट इनपुट। So whatever the heat is given, that all is converted into work. In other processes, some is stored in internal energy. For example, constant pressure है, तो क्या हो रहा? So whatever you are giving, some is stored and some is given as work. But in isothermal, whatever is given, it is internally converted into work. So ये confuse मत होना sir. How can complete heat be converted into work? It can be converted in a process, but not in a cycle. Hope this concept is clear. Hope this concept is clear. Hey bro. क्लियर? वाह, तो आइसोथर्मल प्रोसेस में वर्क होता है। नेक्स्ट, Now we'll go for the next process. Now we'll go for the next process, that is adiabatic process. Adiabatic में क्या होता है? Heat transfer is zero. Adiabatic में क्या होता है? Heat transfer is zero. What does it mean? Neither you are supplying heat nor the heat is taken away from the system. You are neither giving heat nor the system is losing heat. Two-way heat transfer is cut off. That is adiabatic. Now देखो example. सुनो carefully. Example. Now there is a container. In a container there is some chemical. And all this is insulated, perfectly insulated. मान लो there is a container. In a container there is a chemical. Let it undergo exothermic reaction. Listen carefully, sirs. Let it undergo exothermic reaction. Let it undergo exothermic reaction. मतलब heat release हो रहा है. What will happen to the temperature? Anyone in the class? This is my system. अरे यार, एक कंटेनर है, उस कंटेनर में केमिकल है. Or that chemical is undergoing some reaction. Say it is exothermic reaction, in which the heat is liberated. तो temperature क्या हो रहा है? बढ़ रहा है. Is it adiabatic? Yes. In adiabatic, from the boundary, no heat is transferred. Why the temperature is increasing? Because due to chemical reaction, the energy is released. As it is an exothermic reaction, the heat is released and thereby the temperature is increasing. It is adiabatic. Why? Because from the boundary, no heat is transferred. So confuse mat hona sir. Adiabatic mein, even though there is no heat transfer, but the temperature of the system can change. So one question can be asked, is this system violating conservation of energy? क्योंकि temperature अपने आप बढ़ रहा है. It's not violating conservation of energy. Originally, the energy was in chemical form. Now it is converted into heat form. Originally, the energy was in chemical form. Now it is converted into heat form. वो exam में पूछ सकता देखो. In an insulated container, a chemical is kept and the exothermic reaction is occurring, and thereby the temperature of the system is increasing. So therefore, the energy of the system is increasing. Galat. Energy of the system is constant. Originally, it was in chemical form. Now, whatever the chemical energy form was there, it is converted into thermal or heat form. So please note down that in adiabatic process, always remember there can be temperature change. Is it okay? Yes. Aryan Patel has given the right answer. Wonderful students of India. देखो. Now, my dear students, देखो. There is one equation for adiabatic process. PV power gamma is equal to constant. Most of you may be knowing everything about this equation, but let me quickly brush up. This is applicable only when the process is reversible and adiabatic. And the working fluid must be ideal gas. And please note down that you can apply this equation for closed system as well as open system. Please note down that. So if the fluid is flowing, there is a pipe or nozzle, and it is insulated. Let us say it is flowing reversibly, no friction, nothing. Okay. So I can apply this. Open system के लिए apply कर सकते हैं, closed system के लिए apply कर सकते हैं. Now what is gamma? Gamma is nothing but ratio of specific heats. This is specific heat at constant pressure. This is specific heat at constant volume. My dear students, Cp is always greater than Cv because Cp के अंदर क्या होता है? Internal energy भी होता है, work भी होता है. कैसे सर? इधर देखो. Look at carefully. In a constant volume process, देखो. In a constant volume process, and this is constant volume and this is constant pressure. Now supply heat. Look at carefully. ध्यान से सुनो. In constant volume process, whatever the heat is supplied, it is stored in the form of internal energy. But in constant pressure process, whatever heat you are supplying, some part is stored and some is used in raising the piston, means work is done. So Cp is always greater than Cv because Cp has two components. One is internal energy and other is external work. Whereas Cv has only internal energy. Now he may be asking one question. When can Cp and Cv be same? Only when the external work is zero. For example, if you take solids, if you take liquids, इस piston के अंदर एक solid ले लेना और heat करना, it will not raise the piston. But in the piston, in this cylinder, if there is a gas, definitely it will expand and raise the weight. So work is done in this case if there is a gas. But अगर solid रख दिए इस piston cylinder के अंदर, वो वेट्स रेज नहीं करेगा, बिकॉज द एक्सपेंशन वर्क इज नेग्लिजिबल. सो इसीलिए सॉलिड्स और लिक्विड्स के लिए एक ही स्पेसिफिक हीट होता है, दैट इज सीपी और सीवी और सी, एंड गैसेस के लिए सीपी एंड सीवी होता है. अब देखो, जनरली माय डियर स्टूडेंट्स, दिस गामा, look at carefully, gamma, and it depends on the type of gas, whether it is monoatomic or diatomic or polyatomic. So monoatomic 1.67. What are the examples of monoatomic? Argon, helium, so krypton, like 1.67 होता है. And diatomic, oxygen, nitrogen, क्या होता है? 1.4. air 1.4. and polyatomic, it is 1.33, something like this. So ये gamma gas पे depend होता है. So for adiabatic process, PV power gamma is constant. Look at carefully. You can apply for open system, you can apply for closed system, but the conditions for applying this equation is, there are three conditions. What are those three conditions, my dear students? What are those three conditions? Let me tell you. What are those three conditions? The three conditions are, the process must be reversible. One second, please. The process must be reversible. It has to be adiabatic and it should be ideal gas. If these three conditions are satisfied, then only you apply this equation. If any of these three conditions, out of these three, any one is not satisfied, don't apply this equation. Please बताइए, are we clear? बोलो sirs. So what are the conditions? To apply PV power gamma is equal to constant, it should be ideal gas, it should be reversible process, it should be adiabatic process, and you can apply for open or closed system. There is no problem at all. No problem. Sir, सबके लिए है. Don't say closed. Okay, right. Now have a look at this. तो अब देखना, इसी से when I combine these equations, I'll get, so P1 V1 gamma is equal to P2 V2 gamma. Correct na? And what I do is, I will take the value of P in terms of V. अरे यार, P can be written as MRT by V. I'll put the value of P here. I'll get the relationship between TV. So I'll get T1 V1 gamma minus 1 is equal to T2 V2 gamma minus 1. And the third equation is T2 by T1 is equal to P2 by P1 power gamma minus 1 by gamma. All these three are applicable for an ideal gas undergoing reversible adiabatic process. Depending on your requirement, you can apply, my dear students. Is it clear? Depending on your requirement, you can apply. There is no problem at all. And if you want adiabatic work, P1 V1 minus P2 V2 by gamma minus 1. अगर adiabatic work चाहिए तो P1 V1 minus, how do I get? Same integral PdV. Dear students, whenever I use PdV, it has to be reversible, it has to be adiabatic. But now I'm using adiabatic condition also. कैसे? So I'm replacing P with P as C by V power gamma. If I put P as C by V power gamma, means I'm using for adiabatic. So therefore, this equation of work is equal to P1 V1 minus P2 V2 by gamma minus 1. Can you tell me conditions for this? आप बताइए sir. Can anyone tell conditions for this equation? Can anyone tell conditions for this? फटाफट बताओ. Don't waste time. फटाफट बताओ. All conditions. Fast. Only reversible. Sir, क्या हो रहा है सर? क्या हो रहा है सर? Reversible. Ideal gas. Adiabatic. Blindly आप equations को याद मत रखना सर. Blindly don't by heart equations. You should know the background of equations. अब देखो, can we write this as PV is MRT? I will write MRT1. One student said, sir, why are you not writing M1 R1 T1? अरे यार, it is a closed system. Whether it is initial mass or final mass, is the mass changing? No, na. So therefore, M is same. Why are you not writing R1 R2? Gas is same. Whenever the gas is same, characteristic gas constant is same. So therefore, what is P2 V2? MRT2 by gamma minus 1. Look at. So work is given by, let me take, dear students, MR by gamma minus 1, T1 minus T2. Is it correct? MR को बाहर लेना. Okay, right. And please note on that CV is equal to R by gamma minus 1 and CP is equal to gamma R by gamma minus 1 and CP minus CV is equal to R. All these are valid only for ideal gas. not for any other gas. All these are valid only for ideal gas. So therefore, now you tell me, what can I write for this R by gamma minus 1? So R by gamma minus 1 को क्या लिखूंगा? Work is equal to M. R by gamma minus 1 is CV into T1 minus T2. Very good, sirs. And you know very well, for an ideal gas, MCVT is internal energy. MCVT is internal energy. This can be written as MCVT1 is U1, MCVT2 is U2. So therefore, W is equal to U1 minus U2, or W is equal to minus of U2 minus U1, or W is equal to minus DU. Excellent, sirs. तो क्या मैं इसको ऐसे लिख सकता हूं? You know, first law of thermodynamics is, for a closed system is this, and for adiabatic, this is 0. This is 0. When this is 0, what will be the work? Work is equal to minus du. वही तो आ गया sir, वही तो आ गया. So whatever you do, you'll get the same thing. Is it okay? Is this clear, dear students? वाह, अब देखते हैं सर. Very important. चलो चलो आगे बढ़ते हैं. Let's not waste time. सब सही चल रहा है सर? Is this space okay? Is this space okay? आपका टाइम वेस्ट नहीं हो रहा है ना सर? प्लीज मेरा रिक्वेस्ट एक ही है कि ऐसा नहीं कि कुछ भी क्लासेस लेके आपका टाइम वेस्ट करके मेरा व्यूज बढ़ाना, ये नहीं है सर. अगर आप बोल रहे हैं कि टाइम वेस्ट हो रहा है तो आई विल स्टॉप इट, बिकॉज दिस इज द क्रूशियल टाइम फॉर अस. दिस इज द क्रूशियल टाइम फॉर अस. इफ यू से सर मजा नहीं आ रहा है, टाइम वेस्ट हो रहा है, आई डोंट माइंड सर, बिकॉज फाइनली इट इज योर वेलफेयर. तो ऐसा नहीं कि हम पढ़ाते जा रहे हैं, व्यूज बढ़ा के हम इतना व्यूज है, इतना व्यूज है. व्यूज से मजा नहीं, नंबर ऑफ आवर्स बच्चे जो देख रहे हैं वो मैटर करता है. इज दिस फाइन? ओके, थैंक यू सर, थैंक यू. चलो आगे बढ़ते हैं. वंडरफुल सर. सेशन कितना लंबा होगा? जब तक मेरा पेशेंस है. आज दिन भर तो क्लास लिया ना रे. चलो कोई बात नहीं, जस्ट एक क्विक रिवीजन हो रहा है. लास्ट वन इज polytropic process. My dear students, polytropic process एक ऐसा प्रोसेस है जिसमें कोई कंडीशन नहीं है. What do you mean by कोई कंडीशन है? See, if you see the earlier four processes, constant volume, constant pressure, isothermal, adiabatic. In every process there is a condition. In every process there is a condition. Constant volume, volume is constant. Constant pressure, pressure is constant. Isothermal, temperature is constant. Adiabatic, no heat transfer. Means हर एक में एक एक कंडीशन है या नहीं है? है. तो एक ऐसा प्रोसेस है पॉलीट्रॉपिक जिसमें कोई कंडीशन नहीं है सर. देयर इज अ हीट ट्रांसफर, देयर इज अ वर्क ट्रांसफर, प्रेशर कैन चेंज, टेम्परेचर कैन चेंज, वॉल्यूम कैन चेंज. नाउ वन स्टूडेंट आस्क्ड मी अ क्वेश्चन, सर कैन यू गिव मी अ प्रैक्टिकल एग्जांपल ऑफ पॉलीट्रॉपिक प्रोसेस? देखो एक बार देखो, there is a gas in this piston cylinder arrangement. It is connected with a piston and the spring is connected to this piston. Now you supply heat. Some of the students said, sir, it is a constant pressure process. Are namune. Only when the piston is moving at a constant velocity and no other forces are acting on this, then it is a constant pressure process. But yahan pe kya ho raha hai? When you are supplying heat, the spring is compressed. Look at carefully. When you are supplying heat, the gas is expanding. When the gas is expanding, the spring is compressed. When the spring is compressed, there is a spring force which is kx. जितना ज्यादा spring compress होगा, उतना ज्यादा force exert करेगा. Greater is the displacement of the spring. X value is more, kx will be more. So when the spring is compressed, it will always try to come back. So in that process, it will exert an additional pressure. So please note down that additional spring force was not there when the piston is free to move. That's why this was a constant pressure. तो यहाँ पे pressure बढ़ रहा है सर. क्यों बढ़ रहा है सर pressure? Why the pressure is increasing here? Let me explain very clearly. Why the pressure is increasing, sir? आप heat supply कर रहे हैं. When you are supplying heat, the spring piston is moving up. Spring compress हो रहा है. When the spring is compressed, the spring will exert additional pressure. So because to sustain that pressure, the gas pressure is increasing. क्योंकि ये दबा रहा है, so इसीलिए gas का pressure बढ़ रहा है. So it is not a constant pressure process. So pressure is increasing. When you are supplying heat, there is a heat transfer. When you are supplying heat, the temperature is increasing. When you are supplying heat, the gas is expanding, volume is increasing. All are changing. So this is an example of polytropic process. If the spring is linear, you can clearly show how it is varying. So pressure volume का diagram हम simply easily इसको बता सकते हैं sir. When it is a linear spring, I can derive and show it is varying linearly. And area under this curve we can easily calculate. ऐसे questions, my spring के questions, I think I have done 7 to 8 questions in our class. So by taking so many things, okay, no problem. Many changes, very good, very good. Golu Kumar Singh, poly means many. Polytropic changes, many changes. Pressure is changing, volume is changing, temperature is changing. There is a heat transfer. And कुछ नहीं है सर. Polytropic के लिए हम लिखेंगे PV power n is equal to constant. Confuse मत होना सर. Between gamma and n. n का वैल्यू 1 से ज्यादा होता है और गामा से कम होता है. इसका मतलब n is generally, I'm telling, फिर से कंफ्यूज हो गए सर आप. अरे n can vary from minus infinite to plus infinite. It can take any value. But generally, मैं बोल रहा हूं, generally Govind Singh comes to the class at 8 o'clock. What does it mean? Most of the times he comes at 8 o'clock. Does it mean that every time he is coming at 8 o'clock? ऐसा नहीं. Generally n का वैल्यू होता है, ये होता है सर. Generally this is the value. Is it okay? Is it okay? Lag? Is it fine? कोई दिक्कत है सर? Is it okay? एक सेकंड प्लीज, लेट मी चेक. एक सेकंड. One second, please. Yeah. Coming. Okay, right. Sure. Okay. Right. No problem ना. Wonderful. कोई दिक्कत नहीं सर. Now fine. चलो आगे बढ़ते हैं without wasting time. चलो. People said everything is fine. एक सेकंड दीजिए मुझे. Yeah. All fine. Okay, no issues. Wonderful students of India. Is everything fine? ठोको ताली एक बार. बोलो एक बार everything is fine बोलो. Right. हम क्या करेंगे सर? पूरे ग्राफ्स को ड्रॉ करेंगे. सबको हम let's try to represent. Look at every process and what is, देखो polytropic same like adiabatic. तो वर्क क्या होगा? Polytropic work is given by, dear students, polytropic work is given by P1 V1 minus P2 V2 by n minus 1. Similar equations we have. P1 V1 power n is equal to P2 V2 power n. And T1 V1 n minus 1 is equal to T2 V2 n minus 1. Then P2 by P1 or T2 by T1 is equal to P2 by P1 my power. Same like your adiabatic. Lekin the only thing is you have to replace gamma with n. That's it. So all these are valid for reversible, polytropic and closed system. No problem at all. Ab dekho sirs. Look at carefully. Let us represent all processes on PV diagram. Let us represent all processes on PV diagram. देखो एक बार. PV power K is equal to constant. Every process is represented by like this, something like this. अब मुझे बताओ सर, ध्यान से सुनो सर. Clear? हाँ, very good. अब देखो, I want constant pressure. So what should be the value of K? अगर आपको pressure constant चाहिए, तो क्या चाहिए? K को हम 0 पुट करेंगे सर. K को 0 पुट करेंगे. तो v पावर 0, सो इफ k इज इक्वल टू 0, p v पावर 0 इज इक्वल टू कांस्टेंट। ध्यान से सुनो, अगर k को 0 पुट किए तो v पावर 0, व्हाट इज v पावर 0? 1, so p is equal to constant. So when is pressure becoming constant? When k is 0. यहां पुट करो, k is equal to 0 means constant pressure. Likewise I can bring for all processes. अभी करेंगे तो टाइम वेस्ट हो जाएगा सर, क्लास में तो बहुत ब्यूटीफुली डिराइव किया। सो आइसोथर्मल के लिए k is equal to 1 एंड पॉलीट्रॉपिक के लिए k is equal to n, एडियाबैटिक के लिए k is equal to गामा, एंड कांस्टेंट वॉल्यूम के लिए k is equal to infinite. So do you want me to derive for constant volume how k is infinite? अभी वो नहीं करेंगे सर, वेस्ट हो जाएगा सर, टाइम वेस्ट हो जाएगा सर। बासुमता आहा, ओके, इनफाइनाइट, अब वेस्ट नहीं करेंगे सर। ओके देखो, दिस इज कांस्टेंट वॉल्यूम, दिस इज कांस्टेंट प्रेशर, और कांस्टेंट प्रेशर व्हाट इज k 0, उसके बाद 1, उसके बाद k इज इक्वल टू 1, उसके बाद k इज इक्वल टू n, उसके बाद k इज इक्वल टू गामा, देन वी हैव दिस। कैन यू टेल मी व्हाट इज दिस प्रोसेस? दिस इज कांस्टेंट प्रेशर। 1 का मतलब इट इज आइसोथर्मल, एंड n का मतलब पॉलीट्रॉपिक, एंड गामा का मतलब एडियाबैटिक, एंड लास्ट कांस्टेंट वॉल्यूम मींस k इज इक्वल टू इनफाइनाइट, दिस इज कांस्टेंट वॉल्यूम। कैसा सर लॉजिक क्या बताया था मैं क्लास में? आई एम नॉट टेलिंग ऑल दिस लॉजिक्स हियर, क्लास में बहुत सारे लॉजिक्स बताए। 0 से 1 ज्यादा है, 1 से n ज्यादा है, n से गामा ज्यादा है। कैसा सर? आई टोल्ड यू वेरी क्लियरली, जनरली n का वैल्यू 1 और गामा के बीच में होता है। जनरली n वैल्यू इज बिटवीन 1 एंड गामा, 0 से 1, 1 से n, n से गामा, गामा से इनफाइनाइट। इज इट क्लियर डियर? क्लियर? ये एक्सपेंशन के लिए होगा सर। व्हाट डू यू मीन बाय एक्सपेंशन? देखो वॉल्यूम बढ़ रहा है, वॉल्यूम इज इंक्रीजिंग, देखो एक्स एक्सिस राइट साइड जा रहा है, वॉल्यूम इज इंक्रीजिंग, सो देयरफॉर दिस इज एक्सपेंशन जोन। ये सब एक्सपेंशन के लिए। सिमिलरली इफ यू वांट टू राइट फॉर कंप्रेशन, लुक एट केयरफुली। सिमिलरली पासुमता यू आर नॉट अटेंडिंग मैकेनिक्स ना? अच्छा, गेट के लिए बिजी है। अब देखो गेट के बाद पूरा मैकेनिक्स भर जाएगा। अभी तो जून में जैसे क्लासेस चलते हैं वैसा चल रहा है, अब गेट के बाद भर जाएगा। फिर लैग हो रहा है सर, लैग हो रहा है, कोई नहीं। एक्चुअली आई एम एट द डिफरेंट स्टूडियो, नॉट ऑफिशियल स्टूडियो, डिफरेंट स्टूडियो। ये हो रहा है इसलिए प्रॉब्लम हो रहा है, अदरवाइज देयर इज नो प्रॉब्लम। ओके फाइन, सुनो कंप्रेशन। दिस इज कांस्टेंट वॉल्यूम, so n is equal to infinite. This is constant pressure, therefore n or k is equal to 0, correct na? Then 1, this is isothermal, n is 1, उसके बाद polytropic n, ये polytropic, उसके बाद गामा, दिस इज एडियाबैटिक। देखो समझ में आ रहा है सर? 0 n 0 से 1 ज्यादा है, 1 से n इज मोर, n से गामा इज मोर, गामा से इनफाइनाइट इज मोर, दिस इज फॉर कंप्रेशन। वेट, नाउ इफ यू वांट द स्लोप ऑफ आइसोथर्मल प्रोसेस ऑन पीवी डायग्राम, ये पूछ सकता है सर। आर यू रेडी? सब लोग आ जाइए, गेट के बाद मजा आएगा मैकेनिक्स। अभी मैं कुछ नहीं बोलूंगा, आप देख लेना। पीपल आर बिकमिंग इमोशनल आफ्टर क्लास। इतना मेहनत चल रहा है, इतना मेहनत चल रहा है। आपने टॉम में देखा, इंडस्ट्रियल में देखा। ओके चलो देखो, लुक एट केयरफुली, लुक एट। चलो आगे बढ़े सर, आगे बढ़े। वेरी गुड, नो प्रॉब्लम एट ऑल। लुक एट केयरफुली। नाउ लेट्स सी आइसोथर्मल। PV is equal to MRT. Now M is constant, R is constant. Isothermal के लिए I'm talking about isothermal. PV is constant. So I want on PV diagram slope of isothermal. Isothermal slope चाहिए मुझे आइडियल गैस के लिए। ध्यान से सुनो सर। देखो what is the slope? dy by dx, तो dp by dv, p into dv डिफरेंशिएट करना, प्लस v into dp। अरे बाबा, p into dv UV principal ray, P into dV plus V into dP, and the differentiation of constant is 0. So PdV is equal to minus VdP. Slope चाहिए. What is slope? dy by dx. That is dP by dV. What is dP by dV? Minus P by V. This is the slope of isothermal curves on PV diagram. याद रख लेना सर. Same thing. अगर आप PV पावर गामा इज इक्वल टू कांस्टेंट लेके जैसा डिफरेंशिएट किया वैसा करेंगे, आपको स्लोप आएगा माइनस गामा P by V. इसका मतलब ये एडियाबैटिक का स्लोप हो गया सर, एडियाबैटिक का. तो आई विल राइट एडियाबैटिक स्लोप इज इक्वल टू गामा टाइम्स माइनस P by V. गामा टाइम्स माइनस P by V. व्हाट इज माइनस P by V? इट इज आइसोथर्मल स्लोप. याद रख लेना सर. तो ये कुछ एक्सपेक्ट कर रहा हूं सर. आई एम एक्सपेक्टिंग दिस क्वेश्चन. सो प्लीज लुक एट केयरफुली. Adiabatic slope is equal to, I'm expecting this sir, gamma times isothermal slope. हो सकता है isothermal slope, हो सकता है sir. And obviously both the slopes are negative. Yes or no sir? On PV diagram दोनों भी slopes negative है. दोनों भी slopes negative है. Agreed? दोनों भी slopes negative है sir. Both slopes are negative. क्यों? Very common sense says, if I increase the pressure, the volume is decreasing. dP by dV. When one parameter is increased, the other parameter is decreasing. That's why the slope is negative. Both are negative slopes. इधर देखो. So, gamma value is greater than 1. You know very well. What is gamma? Cp by Cv. So, as Cp is greater than Cv, gamma is greater than 1. तो किसका स्लोप ज्यादा होगा सर? नेगेटिव में ही बात करेंगे हम. नेगेटिव में ही. किसका स्लोप ज्यादा? गामा इज ग्रेटर देन 1. So therefore adiabatic slope will be greater than isothermal slope. नेगेटिव के रेस्पेक्ट में. ओके, अब देखो, डोंट डू एनीथिंग सर. दो प्रोसेसेस दिया है. लेट्स टेक टू प्रोसेसेस. दिस इज वन, दिस इज सेकंड. कैन यू सी? कलर नहीं दिख रहा है. कलर नहीं दिख रहा है रे. कलर नहीं दिख रहा है रे. कलर नहीं दिख रहा है रे. हाँ, अब दिख रहा है रे. अब दिख रहा है रे. या अब दिख रहा है, कोई दिक्कत नहीं. नाउ लुक एट सस, लुक एट केयरफुली. सो एक्चुअली स्लोप इज ऑलवेज मेजर्ड विथ रिस्पेक्ट टू पॉजिटिव एक्स एक्सिस. अगर एक ऐसा है तो इन एंटी क्लॉक इज एडियाबैटिक. ध्यान से सुनो सर, ज्यादा स्लोप नेगेटिव के रेस्पेक्ट से, दिस हैज मोर स्लोप, सो दिस एंड दिस विल बी आइसोथर्मल. ओके सर? ओके सर? ओके सर, बोलो रे. ये क्वेश्चन आ सकता है सर. एक सेकंड. One second please. Okay. Okay now? चेक कर रहा हूं सर. आई एम चेकिंग. इज इट ओके? बहुत लैग हो रहा है. अभी ठीक है या नहीं? सो कल मैं अपने स्टूडियो से आ जाऊंगा. अभी ठीक है? इज इट फाइन नाउ? कम ऑन, कम ऑन. नहीं राहुल जी, मैं नेगेटिव के रेस्पेक्ट से बात कर रहा हूं. देखो राहुल जी, देखो मैं नेगेटिव से बात कर रहा हूं सर. वैल्यू तो डेफिनेटली कम है. मैं इसके रेस्पेक्ट से बात कर रहा हूं क्योंकि स्लोप नेगेटिव है, तो मैं इसके रेस्पेक्ट से बात कर रहा हूं सर. आई एम टॉकिंग विथ रेस्पेक्ट टू दिस रेस्पेक्ट, समझ में? नाउ क्लियर, नाउ क्लियर, आई एम टॉकिंग विथ रेस्पेक्ट टू नेगेटिव, इज इट ओके? फाइन फाइन फाइन, क्लियर, नाउ फाइन, कंटिन्यू कीजिए। वंडरफुल सर, वंडरफुल वंडरफुल, करेंगे करेंगे। अभी ठीक है, अभी ठीक है, तो मैं कंटिन्यू करूंगा सर, इफ यू से यस। यहां तक क्लियर हो गया सर सभी को? वंडरफुल स्टूडेंट्स ऑफ इंडिया। कोई दिक्कत हो रहा है या फिर इट्स ओके? डू यू वांट मी टू कंटिन्यू? अब बोलो सर, वॉट एवर यू से आई ओबे, बिकॉज आई डोंट वांट टू वेस्ट योर टाइम। अभी क्लियर है? एक बार ऐसा मारो, ऐसा मारेंगे तो समझ में आ गया कि क्लियर है। बहुत लैग हो रहा है क्या? कुंदन साहब, डॉक्टर कुंदन, हाँ अब सही है, अब सही है सर, नॉट अब सही है, आ गया लॉजिक, आ गया। ओयो ओयो ओयो, चलो कोई बात नहीं। इज इट फाइन? वंडरफुल स्टूडेंट्स ऑफ इंडिया। अब ये हो गया सर, ये भी खत्म हो गया। नाउ विल गो टू, हाँ लेट्स गो टू फर्स्ट लॉ ऑफ टीडी। So the first law of thermodynamics, okay? अब सही है सर, वेरी गुड। So first law of thermodynamics says for a cycle net heat transfer is this is valid only for a cycle. मान लो there is a cycle. First law is also known as conservation of energy. Okay, so net heat transfer is equal to net work transfer, but please note down that it is strictly valid for a cycle. Sir, lag हो रहा है सर। अच्छा, someone said free expansion बता दीजिए। अच्छा ठीक है, तो ऐसा करते हैं सर, ये पता नहीं ठीक चल रहा है, कोई लैग बिग नहीं है, लैग बिग नहीं है ना? ओके, इसके बाद मैं बताऊंगा फ्री एक्सपेंशन, डोंट वरी सर। माय फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स, दिस इज वैलिड ओनली फॉर अ साइकिल। तो फ्रॉम साइकिल वी गेट इक्वेशन दैट इज हीट ट्रांसफर इज इक्वल टू चेंज इन एनर्जी प्लस वर्क ट्रांसफर। ध्यान से सुनो सर, ये इक्वेशन हम ऐसा भी लिख सकते सर। तो आप बोलेंगे सर ऐसा क्यों? So just to show that heat and work are path functions. Thermodynamics में तीन path functions होते हैं सर। One is heat transfer, the other is work transfer, third is entropy generation. तीन होते हैं सर, समझ गए? हाँ, कभी भी कभी हो रहा है। अभी मैं कंटिन्यू करूं या फिर कल करूं, आप बताइए। सो कंटिन्यू करूं या कल करूं? आप जो बोलेंगे वो करेंगे, क्योंकि कल अपने सेट पे जाऊंगा। आप बोलो, कल अपने सेट पे जाऊंगा तो कोई दिक्कत नहीं होगा। कोई लैग ही नहीं है। चलो, दिस इज वैलिड फॉर अ प्रोसेस। नाउ वन स्टूडेंट सेड सर क्यों आप डी डैश क्यू को क्यों लिख रहे हैं? प्लीज नोट डाउन दैट देयर इज नथिंग लाइक डिफरेंस ऑफ हीट, इनिशियल हीट, फाइनल हीट, ऐसा नहीं रहता है सर। Whenever there is a process, during the process you will see heat and work. एक बार process खत्म हो गया, once the process is over, you will never have heat and work. एक बार process हो गया तो there is nothing like heat and work. That's why we call heat and work as energies in transit. Means जो process के दौरान दिखाई देता है। For example, there is a system here. It has a pressure. अंदर पानी है, उसका कोई प्रेशर है? उसका कोई टेम्परेचर है, उसका कोई वॉल्यूम है, दीज आर द प्रॉपर्टीज, बट देयर इज नथिंग लाइक इसके पास इतना हीट है, इसके पास इतना वर्क है, हंसेंगे लोग। द सिस्टम डज नॉट पोजेस आइदर हीट और वर्क। तो आप बोलेंगे सर फिर अंदर क्या है सर? इंटरनल एनर्जी बोलेंगे हम। डोंट से सिस्टम हैज हीट, सिस्टम हैज वर्क, गलत है सर। देयर इज नथिंग लाइक हीट वर्क। कभी भी आप हीट वर्क का शब्द मत यूज करना। हीट ट्रांसफर, वर्क ट्रांसफर, दोस थिंग्स विल कम ओनली व्हेन देयर इज अ प्रोसेस। दैट्स व्हाई वी कॉल देम एज एनर्जीज इन ट्रांजिट। तो जस्ट टू शो दैट दोनों पाथ फंक्शंस है, इसलिए हम just to show that whether I write d dash q or q, it is same. Whether I write d dash w or w, it is same. Don't say that d dash w means w2 minus w1. There is nothing like w2. There is nothing like w1. एक बार प्रोसेस हो गया तो खत्म हो गया, उनका मीनिंग ही खत्म हो गया। Please, my dear students, is it clear? Is it clear? Yes. So the consequences or the results of first law of thermodynamics are, सुनो, first law of heat transfer is a path function. ये कहां से derive करते सर हम? We will be deriving heat transfer is a path function from first law of thermodynamics. From first law से derive करेंगे। तो पूछ सकता सर, according to which law of thermodynamics heat transfer is a path function? It is first law of thermodynamics. Second, consequences of first law, energy is a property, मतलब वो path पे depend नहीं होगा। How many path functions we have seen so far? Heat transfer, work transfer. What does it mean? Different processes, different paths, heat transfer and work transfers will be different, but properties they depend only on endpoints. देखो, that's why we call heat and work, heat transfer and work transfer, not heat work. We call heat transfer and work transfer as inexact differentials. Between 2 points, you will not get same value. If path is different, work is different. If path is different, heat transfer is different. Even though I may be using words heat work, it's not heat work. It is heat transfer, it is work transfer. I may be using heat work, but it's not heat work. It is heat transfer, it is work transfer. Okay, leave it. So it is inexact differential. It is a path function. It's not a property. समझ में आया? They are energies in transit. They are boundary phenomenon. मतलब you will see heat transfer and work transfer only when they cross boundary. जब तक वो boundary cross नहीं करेगा, ना आपको heat दिखेगा, ना आपको work दिखेगा. So let me write everything about heat transfer and work transfer. तो देखो, both are path function. अभी लिख के टाइम वेस्ट नहीं करेंगे, जस्ट मेमोरी में रख लेना. Both heat and work, actually heat transfer and work transfer, both are path functions. Both are inexact differentials, both are not properties, both are boundary phenomena, and both are energies in transit. What do you mean by energies in transit? You will be seeing them only when there is heat and work. उसके बाद कुछ नहीं दिखेगा आपको. Please बताइए, are we clear? Wonderful students of India. यहां तक किसी को कोई प्रॉब्लम नहीं है. Now, so what are the consequences of first law? And third, perpetual motion machine of first kind is impossible. What is perpetual motion of first kind? ध्यान से सुनो. There is no machine, इसको बोलते हैं PMM1, which would develop work continuously without the absorption of any heat. इसका मतलब क्या है? बिना हीट इनपुट से आपको कंटिन्यूसली वर्क कभी भी नहीं मिलेगा. So that is known as perpetual motion machine of first kind. Whenever I use the word perpetual, it is continuous. What is PMM1? ध्यान से सुनो सर. What is PMM1? PMM1 का मतलब होता है perpetual motion machine of first kind. इसका मतलब है there can be no machine which will develop work continuously, without absorbing any heat. बिना हीट से, without absorbing any heat, it cannot. वो तो जाहिर सी बात है सर. हाउ कैन इट? हम तो खाके ही नहीं करते और एक्सपेक्ट कर रहे इंजन से बिना खाए वो वर्क देगा. इट इज अ वायलेशन ऑफ फर्स्ट लॉ ऑफ थर्मोडायनामिक्स फॉर अ साइकिल. वो क्वेश्चन पूछेगा सर, पीएमएम1 किसको वायलेट कर रहा है, प्रोसेस या साइकिल? परपीचुअल मींस ऑलवेज रिमेंबर कंटिन्यूअस. परपीचुअल, क्या पता कल गेट में यही इंग्लिश का क्वेश्चन आएगा आपको इंग्लिश में. परपीचुअल फ्रेंड, परपीचुअल का मतलब कंटिन्यूअस, परपीचुअल का मतलब कंटिन्यूअस. क्या पता कल गेट में अंग्रेजी में यही क्वेश्चन आया तो परपीचुअल का मतलब कंटिन्यूअस. याद रख लेना. लीव इट। कंटिन्यूस का मतलब साइकिल, कंटिन्यूस का मतलब साइकिल। सो पीएमएमएन इज ऑपरेटिंग ऑन साइकिल। इधर देखो, अकॉर्डिंग टू फर्स्ट ऑफ थर्मोडायनामिक्स सिग्मा क्यू इज इक्वल टू सिग्मा डब्ल्यू। यहां पे डब्ल्यू है लेकिन क्यू क्या है, जीरो। सो देयरफॉर आप डब्ल्यू है बोल रहे हैं, क्यू जीरो बोल रहे हैं। सो जब क्यू जीरो है तो डब्ल्यू जीरो होना चाहिए। सो देयरफॉर इट इज वायलेटिंग फर्स्ट लॉ ऑफ थर्मोडायनामिक्स फॉर अ साइकिल। तो पीएमएम वन वायलेट्स फर्स्ट लॉ ऑफ थर्मोडायनामिक्स फॉर अ साइकिल। इज इट क्लियर? इज इट क्लियर? बोलो रे, बोलो 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 बोलो। वंडरफुल स्टूडेंट्स ऑफ इंडिया, वंडरफुल स्टूडेंट्स ऑफ इंडिया। अब सुनो केयरफुली, नाउ प्रोसीड। नाउ there is one term known as enthalpy. We write it as U plus PV. तो अब ये PV क्या है? PV को बोलते हैं हम फ्लो वर्क। अगर किसी को एंथैल्पी के बारे में बहुत ही डिटेल में चाहिए तो आई हैव मेड वन वीडियो ऑन मैकेनिकल का फंडा। चैनल का नेम है मैकेनिकल का फंडा। सारा एंथैल्पी के बारे में आपको हाफ एन आवर में कंप्लीट इंफॉर्मेशन मिलेगा, ब्यूटी मिलेगा। अब वो नहीं शो कर रहा हूं सर मैं, बिकॉज वी आर गोइंग फॉर एग्जामिनेशन। सो एनीवन व्हाट्स कॉन्सेप्चुअली व्हाट एंथैल्पी इज, सो देयर इज वन चैनल दैट इज मैकेनिकल का फंडा। उसके ऊपर मैं कुछ अच्छे वीडियोस बनाए सर, जिसको भी इंटरेस्ट है इंटरव्यू के लिए वो देख सकते हैं। वहां पे एंथैल्पी के ऊपर बहुत ही अच्छा वीडियो बनाया, आप देख सकते हैं। तो पीवी इज नोन एज फ्लो वर्क। सर ये फ्लो वर्क क्या होता है? सर सुनो केयरफुली। जो फ्लूइड कंट्रोल वॉल्यूम के अंदर आने में वर्क हो रहा है। सो नाउ अज्यूम दैट दिस द कंट्रोल वॉल्यूम, द फ्लूइड इज एंटरिंग। सो कंट्रोल वॉल्यूम के अंदर एंटर होने में जो वर्क हो रहा है, कंट्रोल वॉल्यूम से जो बाहर जाने में वर्क हो रहा है, उसको बोलते हैं फ्लो वर्क। व्हाट इज फ्लो वर्क? The work transfer in causing the fluid element either to enter or leave the control volume. So control volume अंदर आने में, control volume बाहर जाने में जो भी वर्क होता है, we call it as flow work. So look at carefully. So now the question comes is, what is that question? Sir, ये किसके लिए अप्लाई करेंगे? My dear students, it is the generalized equation of enthalpy. It is the generalized equation of enthalpy. So H is equal to U plus PV. U is internal energy. इट इज एप्लीकेबल फॉर एनीथिंग। उसके लिए कोई कंडीशन नहीं, रिवर्सिबल, इरिवर्सिबल, क्लोज्ड, ओपन, समझ गए? आइडियल गैस, एनी सब्सटेंस, सो देयर इज नो रेस्ट्रिक्शन फॉर दिस। इज इट क्लियर? इज इट क्लियर? इज इट क्लियर? वंडरफुल सर्स, आगे बढ़ते हैं। तो ध्यान से सुनो सर्स, माय डियर स्टूडेंट्स, लेट अस कैलकुलेट हीट ट्रांसफर फॉर वेरियस प्रोसेस। अब मैं डिराइव नहीं करूंगा सर, वी आर डीलिंग विथ क्लोज्ड सिस्टम। वी आर डीलिंग विथ क्लोज्ड सिस्टम हीट ट्रांसफर। फॉर क्लोज्ड सिस्टम देखो, कांस्टेंट वॉल्यूम वर्क, कांस्टेंट वॉल्यूम के लिए हीट ट्रांसफर इज चेंज इन इंटरनल एनर्जी। फॉर कांस्टेंट प्रेशर हीट ट्रांसफर इज इक्वल टू चेंज इन एंथैल्पी। मैं अब डिराइव नहीं करूंगा सर, एवरीथिंग आई हैव डिराइव्ड इन क्लास। एंड फॉर आइसोथर्मल प्रोसेस heat transfer is equal to work transfer. And for adiabatic process देखो, anyone what is the heat transfer? Adiabatic का मतलब ही no heat transfer. And for polytropic the heat transfer is given by, मैं भूल गया सर, क्या है रे, मैं तो भूल ही गया रे। Is it correct sir? Polytropic heat transfer is equal to gamma minus n by gamma minus 1 into polytropic work. What is polytropic work? P1 V1 minus P2 V2 by n minus 1. Is it correct? बिल्कुल सही है सर। There is one term known as, for constant volume heat transfer we write it as mCV dt. For constant pressure heat transfer we write it as mCP dt. For polytropic process we write it as mC poly dt. अब देखो ये C poly क्या है? And C poly is known as polytropic specific heat. I have derived in class. It is n minus gamma by n minus 1 into CV. याद रख लेना सर, ये इस पे क्वेश्चन आ सकता है। Polytropic specific heat is n minus gamma by n minus into CV. So whenever n is in between 1 and gamma, C poly is negative. इसका मतलब है whenever n is between 1 and gamma, जब 1 और gamma के बीच में n होता है, in that process C poly is negative. What does negative specific heat indicate? इसका मतलब in that process, even though the heat, generally आप heat supply करते हैं तो क्या बढ़ता है सर? टेम्परेचर बढ़ता है। लेकिन ऐसे पॉलीट्रॉपिक प्रोसेस में whenever the n is between 1 and gamma, ऐसे पॉलीट्रॉपिक में जब आप हीट सप्लाई करेंगे तो टेम्परेचर घटेगा। हाँ, तो वन यू में बी सेइंग ऐसा कैसा हो रहा है सर? मैं बताता हूं, सुनो। समवन इज सप्लाइंग, गिविंग यू मनी, फिर भी आपका लेवल कम हो रहा है, पॉसिबल है ये? आपके पास कुछ पैसे है सर, 1000 रुपए है, कोई मुझे 200 रुपए दिया, फिर भी 1000 से कम हो रहा है, कैसे? मेरे से और ज्यादा बाहर जा रहा है, तो इसीलिए वो नेगेटिव हो रहा है. आई हैव 1000 रुपीज, समवन इज गिविंग मी 200 एंड आई एम गिविंग समवन 400. मेरे पास 1000 था तो 200 आ गया तो 1200. आउट ऑफ 1200 मैं 400 दे दिया, तो जो अंदर आ रहा है वो कम है, जो बाहर जा रहा है ज्यादा है. Definitely, even though the heat is supplied, the temperature decreases. So whenever n is between, suno carefully, whenever n is between 1 and gamma, C poly is negative. What does it mean? In this process, when heat is supplied, even though the heat is supplied, the temperature decreases. What is the reason for that? Because the work is greater than heat. जो output मिल रहा है वो ज्यादा है compared to input. Now a beautiful concept will come. Sir, ये तो बहुत ही बढ़िया है सर, जो हीट दे रहे वो तो कम है, इनपुट इज लेस बट आउटपुट ज्यादा है. हम तो 200 रुपए दे रहे लेकिन आउटपुट 400 मिल रहा है, ये तो बहुत अच्छा है सर. व्हाट इज द एफिशिएंसी? इट इज मोर देन 100%. सर हम तो कहीं पढ़े थे एफिशिएंसी कैन नॉट बी ग्रेटर देन 100%. यही तो कंफ्यूजन है आप में. देयर इज अ डिफरेंस बिटवीन प्रोसेस एंड साइकिल. प्रोसेस के लिए एफिशिएंसी 100 से भी ज्यादा हो सकता है, बट साइकिल के लिए एफिशिएंसी कैन नेवर बी ग्रेटर देन 100. इट कैन नॉट बी 100, it is always less than 100, which I'll be discussing in second law. So for a process, yes. So look at carefully, my dear students, understand carefully, look at carefully, have a look at this, have a look at this, have a look at this, look at carefully, please understand, my dear students. Now for a process you can have efficiency greater than 100. So now you may be wondering, look at, 1 second please. Now you may be wondering, 1 second रुको प्लीज, 1 सेकंड दीजिए मुझे. Now yes, exactly. So some students said, सर ये तो बहुत ही बढ़िया है सर. मैं बोला कैसे? हम तो कम दे रहे ज्यादा मिल रहा है, हम तो कम दे रहे हमें ज्यादा मिल रहा है, ये तो बहुत ही बढ़िया है सर. कब तक देगा सर? हाउ लॉन्ग यू आर एक्सपेक्टिंग, हाउ लॉन्ग यू आर एक्सपेक्टिंग, हाउ लॉन्ग यू आर एक्सपेक्टिंग? जब तक इंटरनल एनर्जी है, जब तक इंटरनल एनर्जी है. एक बार इंटरनल एनर्जी खत्म हो गया तो कैन इट गिव मोर देन दैट? नो सर. कैन इट गिव मोर देन दिस? नो. इज इट ओके सर? सो यस, ये तो पेपर पे बहुत अच्छा है सर. सो यू आर गिविंग समथिंग टू दैट, आई एम एडिंग. अरे यार आप 200 दे रहे हैं, उसको मैं अपना जोड़ के एक्स्ट्रा दे रहा हूं, तो कब तक दूंगा मैं? ओनली व्हेन आई हैव सम स्टोर्ड एनर्जी. वंस दैट इज बिकमिंग जीरो, आई कैन नॉट गिव मोर देन दैट. सो देयरफॉर इट इज हाइपोथेटिकल. समझ में आ गया सर? इज इट ओके? वंडरफुल स्टूडेंट्स ऑफ इंडिया. एंड देयरफॉर ये भी हो गया सर. अब देखो, ऑब्जर्व क्लियरली. लेट्स गो टू प्री एक्सपेंशन. It is also known as unrestrained expansion. It is also known as unrestrained expansion. Unrestrained expansion. मतलब there is no resistance. आप बताओ सर. सुनो carefully. सुनो. Pre-expansion और unrestrained. सुनो carefully. मैं आपसे एक क्वेश्चन पूछूंगा सर. आई एम लिफ्टिंग दिस वाटर बॉटल, आई एम लिफ्टिंग दिस पेपर. इसमें वर्क ज्यादा होगा सर. लेट मी रिपीट. इस वाटर बॉटल को लिफ्ट कर रहा हूं, इस पेपर को लिफ्ट कर रहा हूं, इसमें वर्क ज्यादा करना पड़ेगा. यू नो माय डियर स्टूडेंट्स, बोलो रे बोलो. बॉटल में ज्यादा है. क्यों सर? बिकॉज इट इज ऑफरिंग मोर रेजिस्टेंस. इट इज ऑफरिंग मोर रेजिस्टेंस, इसलिए उस रेजिस्टेंस को ओवरकम करने में, इन ऑर्डर टू ओवरकम दैट रेजिस्टेंस, हैव टू डू मोर वर्क. बट दिस पेपर, इट्स रेजिस्टेंस इज लेस. एज द रेजिस्टेंस इज लेस, as the resistance is less, therefore less work is required. फ्री एक्सपेंशन मींस एक्सपेंशन अगेंस्ट वैक्यूम, एक्सपेंशन अगेंस्ट वैक्यूम। तो वैक्यूम में तो कोई रेजिस्टेंस नहीं है, होगा। इधर देखना सर, नाउ लेट दिस बी इंसुलेटेड। यहां पे एक गैस है और यहां पे वैक्यूम है, इधर गैस है और इधर वैक्यूम है, इधर गैस है और इधर वैक्यूम है। वेरी गुड सर। नाउ इस गैस, इस पार्टीशन को रप्चर कर देना। डियर स्टूडेंट्स, यू जस्ट रप्चर दिस पार्टीशन। अब इस पार्टीशन को रप्चर कर देना। लुक एट केयरफुली, इफ आई रप्चर दिस पार्टीशन तो क्या होगा, दिस गैस विल एक्सपैंड अगेंस्ट दिस वैक्यूम, मतलब पूरा फास्ट हो जाएगा। डेफिनेटली इट विल बी वेरी फास्ट। क्यों फास्ट है सर? यहां पे कुछ प्रेशर है, यहां पे जीरो है, देयर इज अ ह्यूज डिफरेंस, सो इट विल बी वेरी फास्ट। व्हेनेवर इट इज फास्ट इट कैन नॉट बी रिवर्सिबल। सो फ्री रिवर्सिबल होने के लिए स्लो होना जरूरी है सर। इतना तेज हो रहा है, देयरफॉर फ्री एक्सपेंशन इज हाईली इरिवर्सिबल, इट इज हाईली इरिवर्सिबल। तो एक्सपेंशन ऑफ गैस अगेंस्ट वैक्यूम, तो वर्क कितना हो रहा है सर? बोलो, वर्क की जीरो। तो आप बोलेंगे सर गैस तो एक्सपेंड हो रहा है ना। अरे नमूने, लुक एट केयरफुली, यहां पे गैस देखो एटमॉस्फेरिक एयर है, तो गैस वर्क कर रहा है, यहां पे वर्क हो रहा है। कैसे? देयर इज अ रेजिस्टेंस ऑफर्ड बाय वेट, देयर इज अ रेजिस्टेंस ऑफर्ड बाय एटमॉस्फेयर। ये दोनों का रेजिस्टेंस ओवरकम करने के लिए तो गैस इज डूइंग वर्क। यहां पे क्या रेजिस्टेंस है? यहां पे क्या रेजिस्टेंस है? जीरो। देयरफॉर देयर इज नो रेजिस्टेंस, देयर इज नो वर्क, सो फ्री एक्सपेंशन वर्क इज जीरो। समझ में आया सर? समझ में आया सर? समझ में आया सर? फ्री एक्सपेंशन वर्क इज जीरो। क्यों जीरो है? एग्जाम में पूछ सकता, because for work there has to be resistance, so for free expansion it is expansion against vacuum, so there is no resistance, there is no work, free expansion work is zero। अब देखो ध्यान से सुनो सर, ब्यूटी देखेंगे सर। लेट्स सी द ब्यूटी हियर। देखो d dash q is equal to du plus d dash w। what is the heat transfer? ये तो insulated है, जीरो। ये इनिशियल है सर, इनिशियल। Let the initial pressure be P1, let the initial volume be V1, this is vacuum। यहां पे कुछ भी नहीं है। Now finally जब ये निकाल दिए, ये गैस पूरा भर गया, so what is this? Let the final pressure be P2, final volume be V2। अरे यार ये तो फ्री एक्सपेंशन है, because it is expansion against vacuum, तो कुछ नहीं है। बहुत इंपॉर्टेंट है सर, ये बहुत इंपॉर्टेंट पॉइंट है। तो व्हाट इज दिस du? व्हाट इज फ्री एक्सपेंशन वर्क? व्हाई द हीट ट्रांसफर इज जीरो? बिकॉज इट इज इंसुलेटेड। व्हाट इज द हीट ट्रांसफर? जीरो। सॉरी, व्हाट इज द वर्क ट्रांसफर? जीरो, बिकॉज फ्री एक्सपेंशन में वर्क जीरो होता है, तो du इज जीरो। व्हाट डू यू मीन बाय du जीरो? फाइनल इंटरनल एनर्जी माइनस इनिशियल इज जीरो, और फाइनल इंटरनल एनर्जी इज इक्वल टू इनिशियल इंटरनल एनर्जी। सो व्हेनेवर अ गैस इज अंडरगोइंग फ्री एक्सपेंशन, इंटरनल एनर्जी इज सेम। और एक बात है सर, फॉर एन आइडियल गैस इंटरनल एनर्जी इज अ फंक्शन ऑफ टेम्परेचर। तो आइडियल गैस के लिए इंटरनल एनर्जी इज अ फंक्शन ऑफ टेम्परेचर, मतलब जब इंटरनल एनर्जी सिर्फ टेम्परेचर पे डिपेंड होता है, एंड दिस इज फॉर ओनली आइडियल गैस, नॉट फॉर एनी अदर गैस, एंड दिस इज नोन एज जूल्स लॉ। व्हाट इज जूल्स लॉ? फॉर एन आइडियल गैस इंटरनल एनर्जी इज अ फंक्शन ऑफ टेम्परेचर। अब देखो, जब इंटरनल एनर्जी सेम है, इसका मतलब क्या होगा? इंटरनल एनर्जी डिपेंड्स ऑन टेम्परेचर। व्हेन इंटरनल एनर्जी इज सेम, द फाइनल एंड इनिशियल टेम्परेचर्स आर सेम। यहां पे कंफ्यूज मत होना सर, इनिशियल फाइनल टेम्परेचर सेम है, इससे कंक्लूड मत करना कि इट इज एन आइसोथर्मल। सी प्लीज डू नॉट कंक्लूड दैट जस्ट बाय लुकिंग एट इनिशियल एंड फाइनल टेम्परेचर्स द प्रोसेस इज आइसोथर्मल। नो, सो आइसोथर्मल प्रोसेस होने के लिए द टेम्परेचर शुड बी सेम थ्रू आउट द प्रोसेस, throughout the process, हर एक point should pass through same temperature. But here it's something like this, my dear students. In free expansion, जब initially ये temperature है, यहां पे अगर temperature लिए, तो initially अगर ये temperature है, गैस एक्सपैंड होते हुए टेम्परेचर घट रहा है। क्यों घट रहा है? सो जब आप कंप्रेस करेंगे तो टेम्परेचर बढ़ेगा, जब एक्सपैंड हो रहा है तो पोटेंशियल एनर्जी बढ़ रहा है, तो काइनेटिक एनर्जी घट रहा है। देयरफॉर व्हाट इज हैपनिंग? सो टेम्परेचर इज अ फंक्शन ऑफ वेलोसिटी ऑफ मॉलिक्यूल्स, सो एज द पोटेंशियल एनर्जी इज इंक्रीजिंग, एज द काइनेटिक एनर्जी इज डिक्रीजिंग, द वेलोसिटी इज डिक्रीजिंग, सो टेम्परेचर घट रहा है। जब टेम्परेचर घट रहा है, फिर बाद में गैसेस एक्सपैंड होने के बाद मॉलिक्यूल्स आके फिर वॉल से टकराएंगे। आई एम नॉट टॉकिंग अबाउट इंटरमॉलिक्यूलर फोर्सेस, आइडियल गैस में इंटरमॉलिक्यूलर फोर्सेस नहीं रहते। सो व्हेन मॉलिक्यूल्स कम इन कांटेक्ट विद दिस वॉल, due to friction, again the temperature is increasing because it is insulated, so again the temperature is increasing. Matlab, even though the initial and final temperatures are same, but during the process the temperature is not same. Therefore free expansion of an ideal gas is not an isothermal process. सिर्फ initial final temperatures बराबर होते हैं, लेकिन please understand carefully. Similarly, you know that UF is equal to UI. अभी देखें, TF is equal to TA, and you know enthalpy is equal to U plus PV. For an ideal gas, already you know, internal energy is a function of temperature. For ideal gas, PV is MRT. Mass is constant, R is constant. This is temperature, this is temperature. So enthalpy of an ideal gas is also a function of temperature. So when the temperature is same, enthalpy is also same for ideal gas. So याद रख लेना sirs, whenever an ideal gas is undergoing free expansion, three conditions must be remembered. UI is equal to UF. Ti is equal to Tf, Hi is equal to Hf. So internal energy and enthalpy of an ideal gas are functions of temperature only. और एक बात इधर आइए. Now the question is, sir, इस बार एक क्वेश्चन आ सकता सर, फ्री एक्सपेंशन पे यही क्वेश्चन देख लेंगे सर. मान लो यही क्वेश्चन है, इधर देखो सर, देखो, an ideal gas, there is a container with 10 centimeter cube. एक सेकंड, यही क्वेश्चन आ सकता, क्या पता. There is a container with a volume of 50 centimeter cube and the initial pressure, there is a container volume, ये container का total volume. So therefore, on this side there is a gas with 20 centimeter cube volume and the initial pressure of the gas is 10 bar. And the gas is undergoing free expansion. The gas is undergoing, it is an ideal gas, it is undergoing free expansion. What is the final pressure? ये क्वेश्चन आ सकता है सर, what is the final pressure? अब देखो, you know very well, whatever the mass of this gas is there, whether it is this mass or this mass, it is same because it is vacuum. Because it is vacuum. तो ये मास या ये मास तो सेम है. I repeat sir, ये मास तो exactly same है. This mass or this mass is exactly same. So therefore equate करना, PV is equal to MRT. So therefore mass is equal to PV by RT. तो यहां का मास लिखो P1 V1 by RT1. यहां का मास लिखो, यहां का whether it is this mass or this mass, it is same because originally gas is occupying this volume. After expansion, it is occupying the complete volume. But what is the mass? Whether it is this mass or this mass, it is same. So initial condition mass, final condition mass. Exactly. Whenever an ideal gas is undergoing free expansion, initial temperature and final temperatures are same. R is same. So therefore, P1 V1 is equal to P2 V2. So P1 is given as 10 bar. V1 is how much it is occupying? 20. Can you tell me what is the final volume occupied by the gas? The same gas is occupying 50 container volume. पहले 20 था, अब 50 हो गया. So therefore it is 50. So ये कितना हो गया सर? ये गया, अभी कुछ बचा है सर. So P2 is equal to 4 आ रहा है. Is it correct? Wonderful sir. वाह वाह, रात बहुत हो गया, अब यहां तक रोक देंगे, फिर हम सफर जारी करेंगे. सो आई एम स्टॉपिंग हियर माय डियर स्टूडेंट्स. शायद आपको क्लास ठीक लगा होगा, कुछ फायदा हुआ. 2 घंटे में मैक्सिमम रिवीजन तो हो गया सर. अब नेक्स्ट क्लास में सेकंड लॉ, एंट्रोपी, अवेलेबिलिटी, प्योर सब्सटेंसेस. ओके सर? ओके सर. थैंक यू. सो जो लोग नए हैं, अभी तक मेरे से नहीं जुड़े, दिस इज माई नंबर, यू कैन कॉन्टैक्ट. अभी कॉल मत करना. चलो आज के लिए बस इतना. थैंक यू माय डियर स्टूडेंट्स. बाय बाय. Thank you. Love you all. All the best for your GATE examination. So on unacademy plus, I'm starting basic thermodynamics for various examinations, GATE, ESA, civil services mains and IRMS on 10th February. 8:30 PM to 10:30 PM. ओके, 10th फरवरी से डेट अनाउंस हो गया, ऑलरेडी मैकेनिक्स स्टार्ट होके 7-8 दिन ही हुआ, वो भी जारी है. सो थैंक यू माय डियर स्टूडेंट्स, गुड नाइट.